Can you guys see me now? Can you see me now? Can you guys hear me now or see me now? Can you see me now or hear me now? Can you see me or hear me now? One more test. Can you guys hear me? All right, I think I know what happened. Give me a second to fix something here. Got to block my password for a second. Give me just a moment. Just a moment to block my password. I reset something here. Just bear with me. That's my hand over the screen, over the monitor. Okay, we're good. Ah, man. So Google Hangouts was fighting Google with my live video. And Google so I basically set up a block for Google Hangouts. The Google Hangouts had a live phone call going on, and I wasn't there. Now, can you guys hear me still? Let's see how I can do this. Oh, I'm going to put the screen up. So we're looking at a projector right now. You guys are looking at a projector, and I'm going to step in the view a little bit. Let me turn the computer a little bit so I can actually see what you guys are a little bit differently. All right. So I'm going to give a few things. Oh, great. That's not really. Let me scroll down a little bit. Trying to see the projector at the same time, so I can sort of see what I'm showing you guys. Once I step in there, it's got a delay though. All right. Good. Rubber ducky, right? Rubber ducky is the truck. There's a vehicle that's going to wind up in that bridge at the bottom, lying on top of this bridge. Now, I got a pointer also. Okay, good. That's working. We just throw some extra vehicles in here. Backstories, I got this off of eBay. Some guy had it on there for 1 cent. So I figured, if he's selling something for 1 cent, how cute is that, right? So I sell him the 1 cent plus the $3 in shipping, and he sent me 3 other extra toys. That was a long time ago, but I thought that was kind of cute, right? I didn't want to discourage the guy from using eBay, so I gave him his. No one else bid on it. So I figured I'll have a little fun with the guy and enjoy it. He sent me extra toys. All right, so rubber ducky though, that's going to be an important one. And what's kind of cool, this structure. Let me see if I turn the camera a little bit, guys. And you can comment, and I'll check your comments in a second. I'll have to figure that out. Let me step across, and there's a delay, of course. All right, so this is what I want to turn. That's our collapsing structure, if you will. The you know what? I think I could do this a little differently. Hold on. I think if I do this, I get a twofer. Yeah. Yep. Rubber duck. Rubber duck is gonna. You know the way I do presentations though, so you can remember stuff. I got my toy Prius and other cars I could put there, but rubber ducky is very important to us. So this will be our uprights. Now, at the base, they're closer, but it serves our purpose to show you how the two come up. Our cabling comes connections, and possibly through this member. That one I have not been able to verify. But we'll go with through the member for now. This is going to be our multiple sections. This is our bridge deck. To your left here, let me get over. This is where we're going to have the connection that's going to stay in place. And then this section here, we're going to cut this. This is going to be a section that falls to the ground. I've got delay, right? Falls to the ground and turns a certain direction. So I'm doing this live so you guys can add anything you like. I've got members on the floor. I gotta wait for the delay. This will be our bracing that will go here. And I'll zoom out, guys. So you can. Well, you know, maybe I can zoom out now. Maybe I can back it up everything now. I don't need the tight shot. Nope. Gotta wait a few seconds for the delay to catch up. And I'm actually can put this down. I just realized you guys don't need to see the monitor. I just need to be able to see kind of roughly what's going on. Okay, so there we go. So then these are further apart than it is, but this makes it stable for our actions. This is going to be our brace. I gotta wait for the delay myself. That's the brace. These are 4 of these guys. They're shaped. They're actually in that configuration, and there are 4 of them. But I'll use it in this plane so we can see it better. Now, I can see your comments to the right if you've got something to say. I'm going to draw down the center of this. A couple of things here. And then off to the sides here, I'm going to add some dead weight. So dead weight is very important for this thing, right? I need you guys to understand that this was not designed to take those dead loads, the loads that were the Jersey barriers. And I'll show you that with other bridge structures that had the Jersey barriers. That's our Jersey barriers. We're going to add 3 of these Jersey barriers. Give me a second. So 3 rows of these Jersey barriers, and they weigh into, that's going to be 100,000 plus pounds on that bridge easily, on those supports. The Jersey barriers will create creep in the system, and since this is an enclosed system, this works in our favor to learn about it. That this will be, I have different versions of cables, guys, so this would be one. This is going to show you something out, a different story. But right now, I'll grab this one to help you with the story a little bit differently. And it's just a colored a water line. And I'll put an arch in it, if you will. You can tighten that up however you want in your mind. But this is, we'll call this our post-tensioning. We'll call this our tension. This cable wrapped in concrete going down. Now, with that said, now I can use the projector, and let's put the projector back into play with video, and we'll go from there, and we'll tie it all in for you. So let me zoom in on the screen, and yes, the traffic lane dividers, and the concrete, and they weigh, well, let's see how much they weigh. They're 4,000 plus pounds, I think like 4,600. Let's go to this. I've got to turn the laptop toward me. Bear with me. It's like 90-something degrees here, guys. So I'm going to give you data, and we're going to use the data that we know to be true. So let's cut to the chase first. Let's back this out. Let's cut to the chase, and then I'll give you the data that supports the chase. They weigh way more than 1,000 pounds. They weigh like 4,600, I think, something like that. Typically, doesn't matter. It's solid concrete all the way up. The Jersey barriers there might be different design, but they're tens of thousands of pounds on this structure, creating a creep. Now you can see this has a flex in it. This would be, I am not seeing, oh, I switched pages. Hold on. I'm not seeing where I'm talking. I know what's going on. Okay. So, this is basically what creep looks like, guys. If you can see, this has a bow in it. I think this gets elongated because of this dead weight. Move that away. Now, you do have other cables. Okay, let me give you a little quick, let me show you the other span. And got to rotate and wait for it to catch up for you guys. So there's the other span, right? And I kick back a little bit. It's got a little delay in it. Let's see if we got to catch up. Okay, good. So there's the other span, and I have a hot glue gun and everything to help us out. But let's just allow me to cut a piece of string real quickly. And I had to hide my string because I hid it for myself. I hid my other line for myself. it was the cats. I didn't want the cats to eat it. I had a cat die once years ago. He ate string and it got into his intestines, and he died. So I try to keep material like this pretty hidden. So bear with me. This ladder is pretty functional for what we're doing to give you a nice visual. So we don't need much. Okay, my backlighting is getting this. Let's take care of that backlighting. Ducking under and up. Okay. So let's just talk about what do you got here. Hermit says that's a lot of weight. 4 tons a foot. Okay, Hermit foot right. Here we go. Gordon. 4,000 pounds. Here we go, Gordon. So awesome. Thanks, Gordon, for sharing. So now looking at this structure, you guys can imagine that when the weight's in the center, and I'm leaving out the center span here between these two cables, I'd have to back this up to here, roughly. And then you back that one up too also. And you have the board, one section in the middle being connected on each side of these overhangs. Right? So now, on these overhangs, this was not reinforced yet, but the other one was. They had the external cabling added. Looks like we're going to get some fun. This is the new cat. This is Bruce Lee, guys. That's Bruce Lee down there on the ground. Right there. I got everything covered over because of him. He's new. All right, so I really wanted to call him Einstein, but she wouldn't let me call him Einstein, so we had to go with Bruce. Very fast. He's a stray. He adopted us. So he just showed up. Another story. So then we have these Jersey barriers here. Over the years, creating stress on the bridge, creep, pulling down on this guy here. On elongating these sealed up cables and in the system. So it no longer can function as originally designed with the concrete around it, which is, I can only find one with the concrete around it, and this is this Italian structure. Now let's go from here now. You can see that does that, but if I had the other brace at the other brace at the bottom over here going up, cantilever, I'm waiting for it to come into play. And that didn't work. I can do this side. So you can see that the brace would take the load off the center. You see it now level? If we get rid of the brace, we have all the loads now just on the cabling. Now let's go from there. And rotates you guys, give you a different image. Seeing the white cat walk away from the rubble. Seconds. Oh man! And then this one showed up. Yeah, exactly. The white cat was amazing. It wasn't seconds either. That's showing that it was edited. No cat with his amygdala. You know I love the amygdala, guys. Nobody in their right mind and amygdala is going to run over on top of that structure. Even as badass as I am, unless you're a family member that I care about. I'm not running into that rubble that fast to save you. I'm going to do a little more evaluation. So that cat is not instinctively going in there like that. Yeah, a friend of mine used to use that. Why are we getting this? Give me a second, guys. Give me a second to resolve that. I know we're looking at an image of an image, but why? It's repeating image of an image. Why? Let me think about that. So this in theory, oh, I zoomed, and the zoom caused some type of weird action. That was a weird one. So let's go to. Hopefully I'll turn the volume up. Let me put the speaker on it. Yeah, it might get feedback on that. Shoot. This should feedback, and you should get this twice. I don't want you to get that. But let's go with the audio. This one is Genoa Bridge death toll rises. All right, this is an initial video. Let me just get right to the data. And we're going to jump back to that bridge. So let's go. Give me a second. I'm scanning. You know what? I've got to go from left to right in my video. Give me a second here. Left to right. All right. So this is the video we know we saw. Right here is what's so important is not just this, but over here to the right. This is the part, as you guys know, that I said that you'll see the piece of section fall initially. This is before we had the first video, the last videos come out, which I say is backwards, but nevertheless, we can clearly see the way things. This is when I had to theorize how things collapsed, saying to you guys that look, this specific piece down here did not fail first. That's before I had access to the more images from the flyovers that showed me the other things. Reflection off that chrome dome was blinding. Oh yeah, I haven't heard chrome dome in a while. Thanks, Jeff Brown. Man, I'm burning too, man. I get a nice little burn. You can call it a tan. I call it a burn. Look, so there's that section of bridge to the right that's still in place. That has not collapsed. It's still, well, we know that. Now watch this disappear. This, when I start play, don't focus on the middle or over here, the other section. This right here is where it disappears. And give it a second. I've got it in super slow motion. This is a replay. Now it's gone. But you see, products are the part of the structure is falling off to the right, and we still have a piece of structure left, and we know that structure to be the center supports. So there's 4 center supports that meet at the top, not unlike this, but you know, it's a little more concrete here, where they meet, and the cabling doesn't share across from each other besides a bridging that goes from here to here, blocking, bridging, however you want to think of it, bracing, concrete, reinforced. So when you see this thing going down, we see either this one going down first or this one. Frankly, I can't get the depth yet, but I can figure it out through twisting and torque based on that material that's on the ground. And frankly, I didn't get to that yet. So let's go with that. Just give you an idea what you're looking at when you're looking at this. You're looking at the, and I'll put my mouse back there, at the center, and let's back it up just a hair. This is what it's falling over now, and we see a cable attached. And what's significant about the cable being attached is that means it did not break at the top, because you got cabling at the top at this point, and yet the structure to the right is missing. It's no longer in there, and the structure to the left is missing. So how can this the sound fades when you move towards the ladder? Thanks, Gordon. Now I'll put some more bass in my voice for you. Well, feminine it up for you, however you like, man. So anyway, look, back to come on, it's blocking my screen, guys. The wording just jumped up my and every fading away now. Okay, so this means it's pulling over at this point, and yet another one is still left behind. Let's go ahead and do that. So that's gone. We still have another member installed yet to finish itself off. And it's just, boom, it's going off to the right also. She says goodbye, goodbye, good night, Gladys, whatever it is. This again is what I theorized, that the left part of the deck failed first, and then the right part of the deck failed secondarily. So back to this, when I said I'm not sure how they connected these members, if they just travel across, or if they're anchored on each side. Well, if it would just travel across, it wouldn't be able to pull anything down, would it? It would just unthread itself. As this pulled down, it would just unthread itself. So I don't have the specs on that, but my thinking, it's anchored on each side, anchored. So now that's how we get that side falling first, and then this pulling down as the lower deck starts to fail. The lower deck, let me see, I'm not sure what you guys can see in the video because I'm trying to stay in frame. Okay, and so I didn't stay in frame good enough. So I'll redo that, guys. I'll redo it. So let's go back over here again. And again, the anchoring is what we're talking about here. If it just went over the top, through it, so it was a balance for each side of this, if you will, then this would have just unthreaded itself. But it didn't. It was anchored, and as that's already collapsed, this side starts collapsing because the deck is pulling down on it. It can't hold itself, and as the deck pulls down, it then pulls 1 and 2 over. Well, 1 and 2. And you can figure out which one 1 and 2 is by looking on the ground and seeing what's stacked on it. I think it's this member to the right went over first, this member out here, and then this went over secondarily. This member, because we see it on top. We see that when you look at the debris, and I'm visualizing it, you see that from the break at the ground, you see that this member's on top. So that means that the member's furthest away would have been the one that pulled down first, showing that torque of the deck going down. Pulling at the top across with that reinforcement, which I showed in another fast video that I did, putting stress on this one out here, then pulling it down also. Now we'll get to it. Let me put this back on there. And let's just watch this deflection. Just to the weight of the cabling. All that stuff's dead load. The concrete added is dead load. All right. So now let's come back to here. And I'll see if you got any comments for me. Hopefully I talk loud enough that time. I'm still refreshing that same comment. Let's go with, let me zoom in. And I wish I could do both, share the screen and talk to you guys, but it turns out I have to do it this way to be able to share the screen and talk to you. Even though I purchased a camera that was supposed to do this, that didn't work. That camera will not live stream as they said. So they bite. So we're back to this technique. So I'm saying it's the furthest one. This is the second one. And remember, the collapse didn't initiate from this end, but I didn't have that data of the other, of the car on top yet. Not until they did a helicopter flyover. And let's go. And then that's when I was able to verify that. And that's your flash of lightning, quotes lightning, which I think is really just the electrical cables in the bridge grounding out. All right, so that's off the list. That one is, and we've got. This guy did a YouTube video, and he was at 500 hits last night. Now he's at 10,900. Oh my gosh. This is the false data that can really screw up a lot of things, guys. A lot of things. And I don't have this software, so tough shit. All right, so, and this software is terrible. Outside engineers said the weight and speed limits should have been put on the bridge long ago. No, I agree what you're saying, but that's a way to circumvent your repairs by cutting down the amount of dead loads. They should have, those engineers are obviously, and I, you know me guys, I'm not soft, I attack. Those engineers are stupid as shit if none of them could see the dead loads at it, that is the Jersey barriers. You should lighten the load. An Italian engine called bridge a failure of engineering. I doubt that, and they keep attacking a failure of engineering. If that's the case, you're so damn smart, then why didn't they get together and condemn the bridge? No. Now, I'm going to show that that's not true. Let's come back to that, and I'll show it to you right now. I'll show that to you now. Now, you guys know about my cantilever action I have with this bridge, how it failed, cantilevering over. But what I'm showing you is that this bridge is the same bridge. 1, 2, 3, 4, 5, 6 of the same guys. And if you look this up, they're terrible with repairs. And it's been 20 years, they claim, since they worked on this damn structure. Yet, it's standing proudly. So if it's a failure engineering, how come this guy isn't on the ground? So this guy is not on the ground yet, 20 years of neglect, and yet the other bridge did repairs. So they clearly knew of the structural errors in this can't have my cake and eat it too. The structural inefficiencies of that bridge, based on those dead loads, guys, those Jersey barriers. You'll see that when so you see the link of this one. And I'm going to close this out, but I'm showing you this span. And I'm going to close this tab out because, frankly, we don't need it anymore. But I'm going to show you what this one looks like. This one is a bridge over lake, and you guys can see this link there. But this is how, let me zoom in. Pause. This is how it looks behind those concrete stays. Pause. You can see that the connections, how they tie into at the bottom here. Let me see if I can move that around somehow. There we go. I keep getting unpaused. Let me do this. There we go. And let me do this again. But what you notice is no Jersey barriers, guys. They have railings. Now I drove across this vehicle in a truck. Luckily, somebody in a truck went by there and they filmed. Apparently, it wasn't designed to take the amount of traffic it had running on it. No, not at all. SS, look at the structure here. There's same thing. There's same structure. SS, about the same years, same technologies in here, the same builder, the same everything going on. Well, I don't know about the same builder, but the same things going on here. But look at the middle. You've got steel guardrails, and you've got steel guardrails on the outside also. You don't have that dead weight. Then you also have access to your cabling system, your tension system. You see it? You can inspect these guys, and there's no dead weight leaning on them. That is the dead weight of the concrete resting on them. That was supposed to be for keeping it from deteriorating. That was the way of, I guess, I don't know what that junk was. But here's the anchorage. This is where we're going to get to, guys, when we talk about the bridge rotating. You need to visualize this anchorage again, right here. That this is how we're going to get this rotation. And let's get the rotation going on now. Let's get, okay, so this is the, before we do that, this is the bridge the truck driver's going across. You guys can look up the YouTube video, and you can see it's a railing. You see this little teeny curb? That is still, it appears they put the Jersey barriers on top of that curbing. Because I looked at the Jersey barriers real close, and it appears I saw something like this in a few positions. In other words, that weight wasn't even removed. So this is the guy going over the bridge. You see the title of it, and you're going to see the steel members as he rolls up over them. Let's see. And he's going into a prohibited country, if you will. I think it's, here we go, let me back up. Jump forward. And let's get you, I'll pause in a minute. Just going to show you the base of it from this side. That was the air shot from the helicopter, drone-ish. And here's this guy. And you can see how it looks as you drive by. Except for when this bridge had collapsed, you would see concrete, never to be able to visualize it. You have this beautiful guardrail that would help show deflection of your deck also through an inspection, the middle and the outsides. You change that to concrete, segmented concrete button together, that is the Jersey barriers. It's going to be very difficult to do that. Look how beautiful he gave us a shot up in the air, this person. 2,773 views. I'm probably 10 of those views. There's the shape of the system, and as it goes down to the same system as before. This will all tie in for you. Look at the guy, he knew to film that. That was awesome. And he filmed that April 15th, 2018 is when he posted it. We're bouncing out of that video. This is going over the structure into the part that remained. This will be the part that's remaining with it, and there's the reinforced section back here. Exterior reinforced cables were added here, not on the other two members, and that was that's just stupidity, guys. You know, obviously if this needed reinforcement, these guys needed reinforcement. I did show you in one of my first videos how this bridge deck goes up and down. Heck, if I could find that video again, guys, I'd have to find my own video, go through it. But if you recall, we drove across that bridge in somebody's vehicle, and they showed, and I said, ooh, I paused and I said, notice this bridge going up and down. It's no longer, it's showing creep. With that said, the asphalt on this, the wear layer, is about 8 inches approximately. That's a lot of dead load, guys. I do not think this thing was designed for that dead load. Here's our Jersey barriers, solid, butt to butt, all the way down, right, left, and we don't even get the deduct for the railing that was no longer in place because they added this steel fencing on top of it, which is probably almost 1-to-1 on trade-off on weight. So you added this dead weight. I heard a lorry had exploded on it. It survived, and it survived that. Oh, that would be awesome. Data there. Then that just means, again, they should have structurally checked it out. And remember, explosions, though, when they hit a flat surface, they want to go outwards, away from the flat surface. These 3 semi-trailers close to each other is a load of around, those kilograms. So we're going to get rid of this video. You guys see it. And let's bounce to this little lady here. So we already know how this is. This you're looking at when they show that 2 videos. The camera is, look to my mouse here, is off of this building behind here is part of that roof, and we're looking down through this driveway, which is this black asphalt here. And there's one of the taller members, the one of those guys, ladder. It's one of those guys there, but it's on the outside. It's back, one of these guys from the back side. These guys let rest on top. They did not make it around the back side, I do not think, at this time. Retrofit, he's saying retrofit with the extra bracing in one place, does that transfer more stress to? You think it would? You think it would? We don't. I couldn't find access to the retrofit, and I wanted to get this video going because I was still waiting for the home run video to pop up. This saved me a lot of speculation. I'm reading a comment. Jersey Bears weigh 4,000 pounds each. 10, 2, 36 tall ones. Those are much taller. I'd have to agree with you on that. And let me see the rest of the comment. I got to tap my screen, guys. Once the connected fails, there is both a lateral torsion and balance. Yep. Okay. Yeah, we're gonna get to this failure, and we need to explain a few things. But I need to get the background. And with that said, let me grab my notes, and you guys can see my notes, and don't try to interpret them, because the way I write is I interpret my own notes differently myself. The only break has to be behind the cable and the sag. Okay, so let me read that off to you. Well, that's in our way, isn't it? Let's go to here. So my notes, let me read that. I can look at my notes and do that, and you guys can try to jump the gun and read my notes, but my interpretation of my notes will be different. So the only break has to be behind the cable, and the sag in the deck allows the connection of a shove of the material deck, of the material slash deck, and a slight rotation before the weight of the objects break free. So if I can't have the break. Let me make sure you guys can see me. Let me look at the video. Yeah, just trying to see how far you guys can see out. Okay. So I can't have the break. The break. That was light, I didn't want my face. The break is not beyond this point. We know that because that structure is still. The break is from here. We have a break here, right? Just back the barrier up. So let's call this the break, which means also I have to have this still connected. Right about there. And I'll change my connection to a string. And now I have to turn my glue gun on. Okay. Let me make sure you guys can see that. Lock your camera view a little bit. Okay, good, good. All right. So now I say we have to have our break here somewhere. Between these two barriers. Right about here is where I'm working on. So visually you should be able to see that. Let me get you guys going on that. Okay, good. We have to have it back here, because if this just collapsed, you can't get. You need a break here, because we need rotation on the surviving piece, the piece that's down on the ground. Remember, if it just collapsed, it would be in line with the structure. But we have multiple sections. We have a section here that's rotated underneath of that structure, underneath the existing structure on railroad tracks. Underneath, not away from it, underneath. So how do you get this material underneath there? I'll give you a rough idea, and then we'll get to it. This breaks here. As this other section starts to cantilever down, it gives a push on that, a shove, and it's already started its descent, guys. So I'm going to get it all together for you. So it already starts its descent like this. When this right side starts to fall down, you see, as it falls backwards, it pushes. Now we need to rotate, right? As this pushes, because we know this right side is going to flip like that and wound up with a car, rubber ducky, inside of it, on the ground. So let's come back. So we just can't have this going like this and falling down, because that's not how it happened in real life. In real life, this section here is rotated in this direction here. And this bridge is going in this direction. There's two different planes there. And we have a problem with this. The other front section of this bridge, this small section here, is underneath of this bridge, apparently, above the train tracks, and it's also turned. So how do you get that to turn if it's by itself? You need the rotation from a cable. You need the rotation from the cable to turn it. You can't turn it otherwise. You also need a shoving, a direction change, pushing this structure, pushing that section of the bridge underneath of there. It has to go underneath as it's falling. There's no connection at the ground that pushed it like a piano. There's no connection like this that allowed it to push and rotate. That didn't take place on the ground. There's no ruts in the ground or anything else. I looked for all that craziness. Didn't find anything. What I do have is a failure going here. And as it's trying to hold on, that right side, perhaps this side rather, breaks free. This side fails first. The right side is still holding. That gets that right torque going on. Well, this rotation, all right? You can call it right, left, however you're looking at it. So it gets this rotation going on as this is pushing down to start to do its flip over. It breaks free at some point. We know this as it rotates around. It then does the shove here, shoving it away. It's got an expansion joint. It breaks free, and I won't waste this piece on that yet. I guess I can. So this is our section here. Of course, it's been changed to scale. And here is our great. I need my orange cable. How do I do it? All right, so we get a rotation here. If you can imagine it, if this side's already broken free, this has failed, right? So it did a turn like that. Put on that side. So then it rotates as it's falling. It's rotating it. It's an expansion joint. It doesn't stay together. It gets its little shove off, if you will. This still maintains the speed rotation of going down to the right. This section here is this. Don't be confused. It's still this section here. It lands first on the outside. This is still taking an action from this guy. Wait till I show you a video. But this is taking the action from this guy that allows it to flip over. The existing bridge to the right is still in place when Rubber Ducky Man, who lives, that's the football player, he winds up on top of this structure. Now he can't recall how he got there, but you can imagine that he got there just dropping off the damn structure. That one's amazing. That's an amazing defeat right there, guys. That was an amazing feat, Rubber Ducky Man. And he lived. He's the one that doesn't recall what happened. That's his car. He says it's inside the bridge, or at least reportedly inside the bridge. That's his car. And let's go to his car. And we'll get back to my notes in a minute. And let's get to your notes first. 45-meter fall. That silver Volkswagen Touareg looks relatively in reasonable shape. Good to hear the driver survived. Yeah, he was a soccer player, supposedly. Football player, they call it. So back to this. And he's over here. And that was in the other images I showed. Let's see if we can... do this. Give me a second. I'm going to zoom this in. Because the video is the one that saved me. With the night vision now. I'm not talking, guys. I'm not talking. Okay, so there's a rotation on the far end. This implies that by no uncertain terms that this cable was connected, and it held on until it popped. It held on, spun it around out of plane of the just falling down. Like this just fell down here. So that cable was still connected, and that's this cable. That's this cable. As it was falling, I hope you guys can see that. Let me see what my range. I might be stepping out of range now, right? SRAM. So if that's the structure, this won't really flex like that, but we'll give it a shot. Yeah. Okay, so if that's the structure, it's embedded like. Let me look at I'm looking at the video too, guys. If this is our connection, and let me see if what you see, and then I can explain, and you guys can visualize it. Oh, I'm blocking the screen. Great. I'm not that bright sometimes. Give me a second. Go this way to see you guys. Good. Making sure you can see it. I wanted to make sure you could see this thing right there. So here's the connection. My arm is this now. And if you can visualize, I'm looking at you guys. I just drop it down, right? And if both of them connected, what's going to happen? If they're both connected, they're just going to fall, right? They're just going to fall all day long. The light's in my face. That's why I look that way. So they're just going to fall all day long together, equally. Now I remove one, but I still got connections back here. So let's remove this arm. And now the bridge starts to fall. We know that this section from here to here falls straight down pretty much. It falls where this hits first, and then it folds backwards, right? Hit and fold backwards. If this is an expansion joint, it breaks free right here. It breaks free. But this cable's length is not changing, guys. My arm aren't going to change. It's not going to change. But this still wants to go down to the ground. It still wants to drop whatever meters, right? But I'm holding on. I'm not going to let go. So as gravity's going down, this thing spins around. I'm still holding on. See my fist holding on? I'm still holding on. But it's still going down. Finally, I don't break at the shoulder. I break at the joint right here where my hand is, which is at the ground. It now takes a dive, boom, buries itself into the ground. Now you can see why you don't see any connections here, because my hand broke free. It broke free. Now it's in the ground. So you see that end of the structure, how you get that. That means that this was in place. That means this was intact. This was not defective up here. Because for me to hold that and spin it around and then release it, I had to have a good shoulder. The shoulder, okay? So if my shoulder had a bad connection at the top, when it spun around, well, then my arm would come off and it would stay with this piece here and it would just fall to the ground, probably more like this, and no rotation would have taken place. Unless it had a few tendons left and I slowly gave it a slight turn. But that's nevertheless, this means it was intact. And the failure, for me to rotate that much, you'd have to do the weight on that section, and you'd see how much it weighed into the hundreds of thousands of pounds, and you would see that cabling had to be connected for it to fall. I'm not going to elongate. I'm not going to stretch that much. I'm going to elongate, but I'm not going to let go. It goes down. It still wants to go to the ground. I release, in the ground. So you see that that's the two connections now that have to be in place now. Well, at least now you can see also why you get this rotation. All right, let's see what your comments are, if you guys are following that rotation story, or did I lose you? Oh, sorry about that. What do you have for me? What do you have from reading comments? He's a pro footballer. VW Will went to the tour. You're doing great, buddy. Thanks, Blind. Alpha Bergen. I wonder how the front steering axle of the truck could have bent to the right. The semi-trailer slide and hit the Jersey barriers. So yeah. So then, well, Blondie comes up with something. What if somebody crashed into that? I left out crashing, guys. In all my little playing around, I'm leaving out crashing. I'll have to give that some consideration, because I was biased. I was looking for creep. I was letting all the data tell me anything, but I didn't add the extra data of a collision. I did add possibly nefarious governmental blowing this shit up. I did add that, but I said, I don't think that, because of the concrete doesn't look like it took an explosive material hit. So that one is I'm taking back. we need let's go back to this thing. We need to get the rotation here. Once we get the rotation there, then you guys will see why your process of elimination, why we're down to here now. So to get a rotation on this one, we know we can't have a failure. We can't have a failure in these columns because it would have just collapsed over. It wouldn't have held over and broke free. Now let's go on to. Let's go on to. Let's get to that image. Oops, I didn't mean to start that video because I don't. Oh, that's a live video. And how do I escape the live video? Do that. All right. Let's finish off this video, and you see the name of it, so you can find it. And there again, there's our piece. There's our missing, my hand, if you will. This is the data from these guys. They're allowed to use their drones, so that was awesome. There's one of the top uprights lying on top. That's the furthest one away. That's the one here, closer to the ladder on our side, guys. That is, put my mouse on it, zoom in. That's this. That's near the base. And as it got pulled over. Now, if another sky shot would have shown me, oh, there it is. This one here is on a diagonal towards this direction. Here's the decking that we see in the video collapsing. And do we need to get to that video? Let's just jump to that and we'll throw it up as data real quick. Oh, my collapse thing. So luckily they did demo a bridge of this style, not quite. But I want to show you this cantilever. Remember my flipping action, guys, that what I showed you? Forget that. I need to find it for you. I got to find the one with the car. Because I'm leaving this video up, I need, other people might not want to have the patience to go through all the videos, right? So let's just work with them for you guys that haven't seen it. All right, so this is that route. Great. Okay, let's just zoom in on that. Fire brigade, they did the drones, tire blow up. So here's that, and that turns out to be a truck, not an ice cream truck or anything else. There's that road decking that did the rotation. That was the one closer to here. I've already shown and talked about how this edge is not deteriorated. There's no breakage there. And now let's get the car. Let's get the rubber ducky. So rubber ducky is right there. So this is in the background. This is where gotcha, Hermit. So you know, I don't have a closed mind yet on that. So then here's that structure that's across the train tracks. We can't see it. It's in the background. That's roughly here. Well, here it is, the fire truck. I thought it was visually, couldn't see it. Here's the football player that survived. He's in the underside of the structure, and let's see if I can do that again for you guys to zoom out. And we'll do a top shot of that too. But where's my piece? Okay, good. So he drove off the damn bridge. I thought he was in the second one over. Huh. He's in the third one over. So he drove off the... Here's Rubber Ducky over here. When he's probably back, which I find amazing, he's probably back here. I just don't know how he got there, guys. Because you're going to see the distance now, Rubber Ducky. He's going to have to haul some ass. He's going to make some distance up and survive the fall. Let's see where I'm going. Let me change the picture. What's Rubber Ducky? Rubber Ducky's got to do a lot of work to get where he is. I just find that amazing. I wanted to see the front of the car, you know, which part of it. I want to know if the airbags went off. I try to let Rubber Ducky come into the crash scene early in the game, and maybe that's it. You know, that when this rotates and flips over, Rubber Ducky. You see the problem? Well, I'll show you the problem, guys, when I start putting it together. Rubber Ducky is so far away. He'd have to be traveling like this crazy amount of speed to come off the top of the structure and wound up on top of here. Now, can you do it in mid-air is what I theorize would be nice to help him sit, and then this goes down, and he goes down together with the structure. the best I could find on these images of Rubber Ducky Man, of this guy. Let me zoom in and get out of the way. Let me make sure I'm there. Give me a second, and I'll show you what the issues I'm having. The best I could find of this guy, this breaking in the top of here is not present over here. Over here I do have some, and here. And I'm going to show you how this typically would, take a frontal impact first. In other words, would this do this and then fall over? This and then fall over? Or did it just do a beautiful full flip and fall together like that? I can work with both, except for if this is the case like this, if it does the flip and fall like that, he comes secondarily. If it does this, he definitely didn't take, what did he do, drive into the structure? It doesn't work because this doesn't fold up here, guys. It folds up down here. And now let's cut to the chase on that one. And let me give you a little data to play with your brain. And we'll come back to that. So let me give you... You almost balanced on the brake. Well, I thought about that, Blonde. I thought about the rotation would be a hell of a ride up. I put that in another video, and I discounted that. Now let's jump to a failure. Here's an explode. This is a demolition of a structure with a cantilever similar to this, which is awesome. And let's. Oh, I got it on super slow motion. Hold on. Let me fast forward it. Okay, so what's awesome here, guys? It's the largest cut. Yeah, good, Doss, excellent, excellent, Doss. Yep. Excellent on all the vehicles, Doss. So this is that. Now, let's just jump on to that. Let's go this. Let's do this. Because it holds like the last 15 minutes in most vehicles, newer vehicles, not older vehicles, they don't have it. But this guy represents our system, roughly, without the center supports though. But what's nice is that this will help us see the two sections joined together. They're gonna put explosives here, and two other points. But you're gonna watch this structure here do my flip over. We know it did it anyway, but we're gonna be able to see it in real life, in real time. You're gonna see it do a flip over. For explosive means, literally explosive means. And here we go. And I have the timing down to like quarter speed. And those are your protective mats, your blast mats, to stop the things from shooting around to the world, right? The explosives behind your blast mats. And that's a tall column structure with the two outside braces. And that's just them showing it. And it doesn't even look like they did too much work as far as removing, weakening the structure. Bear with me, guys. It's the speed they're going to do it at, and they do it, but I want to let you enjoy it too. I jumped 26 seconds. And they put explosives down there too, but let's watch it, explosives. And then watch the cantilever effect, the flipping effect, the rotation, the flip of this guy, not that one. So they remove the section of bridge. Just stop there. Still balanced, right? No failure. You know, this is nice if they could, you know, knowing they're going to remove this, they can duplicate this failure again, guys. They have two other structures they plan on removing, right? I know the houses below would be sacrificed, but you'd be able to duplicate this with those two other structures. The failure, but here we go. And my ass would want to do that. All right. So the one to the left is what I want you to look at. Now they blew the bottom base, but it's still falling equally. And now they blow it in two sections that would marry up for us, because I think the bridge evidently broke in the center here and also here, guys. But this is interesting. At the base here, we're still going, since they only blew it here, we're still going to get this rotation. This cantilever is further out to the left, and this is blown here. This doesn't fall straight down. It takes a knock right there, I believe, in the part to rotate it. And we have that in this structure also. We do have a cross brace in our live structure that has right under there in the real deal that has a brace too. I'm not saying it hit that. I'm not saying it didn't, but I'm saying it flipped 100%. We know that. Watch it take a flip out of nowhere. She's riding down. Remember, this is almost at the ground already, though. She can't ride much. In our true life example, we can only ride maybe to there. But I'll leave the mouse there and I'll press play. But we already have a downward and a slight rotation. But you think from here, looking at it gravitationally wise, you just say, oh, it's going to fall straight down. But we have the bars, the cantilever going on. These guys here are going to give us our flip. Now let's do that. And here comes the flip. Boom. Ah, now look what happened there, guys. Now we get our secondary brake without an explosion effect. No explosions are taking place in as far as I could tell. I don't see anything like that. They then failed at that point. This gives you an idea that maybe we can look for failure towards the bottom of the base also to do this, but not at the ground, at the base. This gives us that effect. But we would need failure at the cables. We're not going to get them both at the same time. Not unless you did something nefarious. But we're just going to continue this and get our rotation. Our belly flop. And here we go. We keep going, going, going. And there's our full rotation coming up now. Look at that. We're now looking here. Now, put the guy's car into this thing now. This bridge is still existing here. This guy drives off into the air. He has some air time while they're still falling, and then he winds up in there. I don't get that, guys. Now you see where the bridge is down here. He's going to wind up here, guys. This is belly flops here. So how does Rubber Ducky go from here to here? Now you see what happened. This part already took a huge arc going down before he does the rotation. Hey, thanks, Gordon. So doing what I can for my brother Peeps on YouTube. Here we go. Let me finish this rotation. But your comment just got up. Let me. I can't narrate it. You're not doing it. It's a lag. Okay, here we go. So there's a rotation coming around. Floop. Now at this point, Rubber Ducky can go take to the air, and maybe wind up in there. It is, isn't it, Bergen? I'm going to give you this shot. Now we do have some slight. For a bias here, we do have a slight column tilt, but we do get the rotation. Let's zoom out, and you guys now have access to the link by seeing it says, whatever it says here. Technomine, blah, blah, blah. Now they hit this a few different angles. I'm not going to waste our time because I think that was the best angle to get you your answer. All right, so now we got the belly flop. We got this guy with some terrible, beautiful hits. Probably getting advertising, I don't. And I actually was going to write them. The Genoa Bridge was a cable stay tight, and incline members are compressive legs. Michael Gilmore. They are compressive legs. So whenever you find compression, I can always find some tension. Compressive legs with tension up here at this joint, at this connection here. As this pulls down, it's pulling on this connection here, putting tension in the middle. In the middle of there. You guys can do it. So don't get too crazy about you know, I know a lot of bridge guys love saying this got to be compression, this got to be tension, and that's it. Things do reversals, you know, they do a reversal. You know, so this has a pulling effect. This has tension inside here pulling on it. So yeah, the load is ideally, if this supersedes that tension, no failure happens at the joint, and it translates the load down in compression. If this was to break, as that's pulling on that side, there's nothing counterbalancing it, so now we have tension on this side of the leg as it's pulling over. So if I'm pulling this way, over here is where I got tension, and I got nothing to hold me back, hold my arm, and as you hold my arm, you pull me back in. Okay, so that's the other side of that. Oh, great. I did a video and you got to see my ugly face, not my demo. Let's do that again. Backing out. Okay, going back out. Come on, go on. I had the right face too, didn't I? Look. So, this is the joint here. This is this leg here. And that's that one. If you cut my arm here, get rid of this one. Right here, all of a sudden, I'm going to suffer tension here. Tension on this side as this tries to hold that extra weight up that's gone over because I'm no longer in balance. If you can balance me now I'm nice and calm, all the loads go down my chest, down my legs, and into the foundation. You cut one arm, and I'm doing this. You loosen one arm, and I'm still doing that. But now what happens, you can see that this is gonna drop, and this is gonna pick up some slack, and ultimately it keeps going, looking like this. But I'm putting now tension down here, because if you guys can feel this is a compression now. This is gone in tension on the sides. So you need to balance this system, holding here and holding here equally. So it takes the load at the joint and straight down. Always making sure my cables are nice and taut. Yes, I'm sweating. It is hot here. It is 90-something degrees outside here. All right. Thanks, SS. Hopefully I didn't look like too much like a fool, but I don't mind. All right, so let's go to here. And this is where we're going to... and you can imagine now, the same thing example with loads. If you can imagine that my arms... And I know where to stand now. Good. So now you can imagine if I was designed just to hold this deck and some steel cables, I'm happy. I'm happy, right? Then all of a sudden you add tens of thousands, 100,000s of more pounds onto me. I'm like, fuck. And now I'm like under strain all the time. So what happens? I start elongating here and here equally because you put the load equally across my deck. I start elongating my cables. This puts a creep into this action here. It starts bowing it. But since you balanced my load, I'm going to be equally under stress until you find that one of my cables starts failing maybe, and then another tendon. Ultimately, then I'm no longer balanced. And now, remember, I got two sides of me. I got this one and that one, and I'm tied at the back together. Another person's there tied at the back together. But I now make this one weaker. It can't hold as much. So what happens? The deck starts creeping down, and now I'm imbalanced again now because this one's now trying to hold. You're back to putting tension on me in here now, trying to support this thing at this point, at my shoulders, at my joint. But I'm still going to do it as long as I can, until eventually maybe this one goes bad. Now it's still going to hold on because you have the redundancy of the deck, the tying of the joints. That one's still holding up a lot of load on that side because now this one's weak. That side starts taking up the load across this, was it two sections? One section here starts transferring the load over there, helping to bridge the gap of this weakened member here, this right arm. Ultimately, it can't do it anymore. This can no longer hold. Then I'm back to the other side. The back side now says, I got you to the front side. I got you. And then bridge says, I'm still going down. It's like, I've got you. I'm still holding on because I'm not going to release. So now this is this section here, guys. This line is this. This line would be here. This is the back side. This is the front side. Now visualize that. This is the back side, and this is the side. And this is the right arm. This is the weak side here now. It's weak, and it says, I've got you. It's now weak, and it's like, I've got you. See the torque action going on there now? I've got the extra load, and this isn't carrying the load. And ultimately, it fails. I've got you. I've got you. We get a slight failure here. No longer can able to transfer the loads over. It starts to fail. This breaks free at the joint. This is still holding on in the right arm. It does the rotation. As it's rotating down, this part flips over to... Remember I just showed you the video. So this does this. See how it's doing the flip? There's our flip that you just saw in the video, the flip over and the collapsing of this at the same time. But we now, as it's going down, this breaks free at the joint here, my finger here, and the cable's still holding on the right side. Does the rotation. As it's doing the rotation and this is flipping down, it gives it a shove outwards. And I don't know how many feet that thing's underneath there, but that's that little shove it needed. And that shove also, it can't grab it. My cable can't. My cable is connected at the top. It can't elongate that fast, that 2 feet or 3 feet, whatever footage it is underneath that structure. It can't elongate, but it took the bump anyway, and now you started my top failing. We've started my joint failing at my shoulder. I'd love to see down there. I can't see. I want to see if this is connected down there, guys. Or is it at the shoulder? Is it still connected at the top? It tells me it failed at one of them because we did a rotation. All right, it was connected at one time at both points, my shoulder and here. You can't get a rotation, guys, just like the other end. You cannot get a rotation if you free this off of this joint here. Make sure I'm in the joint. Make sure I'm in the shot. I don't want to do that again. Okay. So now I'm sticking from this side. I can't get a rotation of that bridge on the ground, and I'll show you the structure again, if you just free me up. If you free me up and you only connect this side of it, this side here, I can't do that either, I don't think. A bump and a rotation. I'd have to see this joint. I'd have to see this joint here, which I wasn't able to find, and I was not able to find either joint here in all my researches. So maybe I could get the other side failing and do a bump. I like this side. I'm open for it. But this is your rotation. But we need to bump forward, and the bump forward would have been this side falling, taking a bounce, breaking free of the joint, rotating, falling down to the ground, and that continues. We'll get more videos. More video, supporting video for that. And let's go. Hopefully you guys any comments? Trapezoid. Trapeze. All right, so let's go on with that. Trapeze. All right, so we're now at the rotation. Where are we? Where are we? Oh, I need the evidence. Hold on, the video shots. Let's so there's the car, and zooming in, guys. Give me a second to zoom in on that. And I'll zoom out a little bit so you can get the full. There's Rubber Ducky, I'm calling him now, right? Here's Rubber Ducky. Rubber Ducky's here. No breakage here from this drone shot, no breakage here. So with that rotation downwards, it took 2 bumps into the... So I looked at the underside of these structures here. These are those braces I showed you where the guy took a secondary hit or breaking in that video. These braces are ×4 locations. One on each outside, one here and one here, which is awesome redundancy. And I mean, literally, it's on the outside edge, but they're actually up here. Here's the points here. See it? 1, 2. I think it's symmetrical. The other one's there, and the other one's there. If you see, if this is here, that means if you could imagine it reattached, this would be the path of it. I'd put it right near the edge. All right. If Rubber Ducky went down and then this did a secondary break, Rubber Ducky, in theory, should be crushed, right? A pancake. Rubber Ducky's an amazing thing to add into my whole formula, but he tells me that the bridge, this collapsed first, because Rubber Ducky, you can't have the other structure, side of the structure collapsing first, and Rubber Ducky make it in here. You know, flipped up into the air, perhaps, 900 feet up into the air, being smart about the footage, and then came flying down and then landed there. You know, yeah, that's a possibility. Okay, I'm playing the video now, and I'm gonna zoom out a little bit, get you guys oriented. Come on, Vic, come on, camera. Oh shit! I knew it. I'm screwing up, guys. I gotta kill the battery. I mean I gotta make the screen real dark. I'm only down. Let me put my GPS on. The damn Google's nasty. I put my GPS on. Hold on, that should have not come on. All right, I had to dull the screen. It's down to 33%. And make sure I'm charging. It says charging. Hopefully it'll come back up. This makes it real difficult for me to view you guys, but I'll have to do multiple things here. Okay, so Rubber Ducky in line with the structure. This is that. All right, let's move on. You can see it better now. And here is our bridge. Here's our train tracks. As we Google Earth this, you'll see the train tracks appear to be, you go above, appear to be underneath for that existing bridge span. And so therefore this is how much of a bump, a major bump it had to take. And you see no connection between here and the next section. And this is where I'm saying this took that, as it was going down, it took a hell of a charge, bump, and it moved under, rotated it, broke free of the expansion joint. And right below this live member here is the next part of the decking that I'm saying is connected, which I couldn't find any video of. And there's my girly girl. Let's see. We'll fast forward to the next one. There's the house for orientation. There are the members, the uprights. It's not the bridge structure, so it's the uprights, guys. We only got a limited amount of uprights. Don't get confused, guys. You only got 2 on each side to go all the way up. They change colors about, some point up there around the bridge deck site. That's great to be able to figure out where it is. And then you got 2 on this side. Same thing. But you can see that the base on this one is all the way to here. And then here's your white. You can put this one practically back to there, and maybe it goes to that one. I can't quite get my depth, but you can see it change colors. So don't get confused by all the rubble. It's more simple than it looks. They're 2 colors. These are accounted for on this side. You simply reconnect them back with following the rebar. Same thing with this, and now you know the connect with it where this stuff orients. Underneath, we can account for all of the members that were supporting this, the 4 members underneath the structure, which were the bracing. Let me see if I can get you the bracing. The bracing here. We can account for those on the other side where the structure does a flip. They're on the ground. We can account for this part of the bridge structure. It's on the ground. I just lost a Jersey barrier. So, it's on the ground. We can account for that section. It is where it is, and we can account for the other small road section. It's on a diagonal from the flip structure. Okay. So don't let this drive you too crazy. You just let me see the comments. Rightwards, that confirms the theory. Do you remember which website? Okay, I'm missing comments. Let me go over here. I can't read the comments on the cell phone, so let me bounce here. So we can't recall things properly when we're in the moment. We're going to mess that up unless you got a lot of training for that. So she may say rightwards, it could be corrupted by anything. Okay, car. So I try to count that as bias data. I'd rather see a video. I've been wrong myself a few times about how I think things transpired. Then I go to video and see otherwise. Alright, so I'm going to... Okay, here we go. So that's the other side. That's that right shoulder gone. I mean, the right hand's gone. The shoulder's in place to be able to rip off. That's that rotation. Here's the centerpiece, guys. Let me zoom out. Can you see it properly? Yep. And I'm going with that. And I'm going to go with the laser. Save me from walking away from the computer. And hopefully the laser will show up. Little bouncy. That's not me this time, guys. That's the fast forwarding and going here. Okay, here we go. Feedback. So again, there's those top members. You see where they are. That means that bridge took that turn in that direction. That last section. Let's see. Oh, SS, got to get some sleep. 1 second, and we'll give you photos and interviews in her name. Yeah. So so then that went that direction. Here's Bugs Bunny. Here's the duck. Look how far it is, guys. I mean, you can do the math. Here's the structure. You see that it fell on top of it, yet there is no bridge. See, there's no bridge here, guys, and I'm going to show you how that separated here. As I zoom, I gotta figure out my bridge. Remember, I'm looking at a dark screen now. You got to bear with me. Yeah, okay. So I'm going to show you how that separated and went two directions. Right here, where it went this way, and that one went that way and then down. Away and down. This one went that way, flipped over. The debris pretty much stayed away from the center column area. This went this way, down, away, and down, right? Using as a member there, possibly the cantilever itself away, pulling itself away as it's going to collapse, but we went away. Not just a straight gravitational straight down. Now, that's good to know because we can eliminate the break in the middle. Well, the break in the middle, right? We can eliminate it didn't come this way. We know that because we can see the products too. But let's go back to the screen and then let me see what you got for me. Okay, so that's playing, and oh yeah, I believe it whiplashed. Some whiplashing took place with the top in the video for sure. And let's go forward. Now here's a drone shot. There again are the columns, the uprights. 1, 2, 3. If you remember the explosion, the demolition bridge, how it failed at this point and at this point. But remember, this you're looking at, guys, is way up here. That's the connection up here. Let me see if I got to tilt the camera for you. It's up there at the top, so if you can see the red laser. That connection is here. The other one is here, and then we have the outside. So 1, 2, can't see it in this image, and then the other one's on the outside. This is on the outside. There's Bugs Bunny. There's the duck, rubber ducky right here, amazingly so. And there's another vehicle here that took a nosedive. Now, so these two cars are behind each other. He wins the nosedive award to making it further out. He does not win the nosedive award. This one winds up probably dead. This guy winds up saying that he doesn't remember what happened. So this one doesn't make it, apparently. This one makes it. We have another vehicle trapped in the inside, guys, in here. You remember they're hanging upside down vehicle inside there? That's not a drive off, right? It's a drive off or a slide back. But let's go from here. Again, there's our road deck, and that's the center of the road deck. You can see it's on an angle now, no longer just a straight fall. It's got that rotation. Hopefully they'll give us the other sky shot. If not, I got it covered anyway. All right, so that's on the other side of the structure where that one piece in the beginning of the video I said, watch, it just falls off the last moment. This is that piece. It does a 1-to-1. It falls off. It rotates from the hinges right from the existing structure where we see that car, the truck on the bridge. That's that piece there. Nothing to speak of besides what right here. That's that piece there right below us. There's that rotating piece. That one fell straight. So see the line? That's the center line. Pretty much that's the center line. This is no longer center line. So if you can follow my arrow, that's center line. But yet my center line is this path now. Those two meet at two different angles. It tells you the rotation. This one is the awesome one to know because it pretty much did a hinge fall flip action and was done with itself, breaking free from this section here. This section here is equivalent to the other section on the other deck that's sitting on the railroad tracks. This section here has the longest maintaining anchorage. As you can see, it took a nosedive straight down as I showed you. There it is again to the top. Hopefully you guys can see it. night shots. There's the bottom of those braces I spoke of, and you can see it's on the outside of this. It's also on the outside of the bridge. There's the next one in. You'll find that the sister of it is on this side, and you would just reverse that. These are the tall uprights, the ladder post, if you will, the ladder, if you call them a ladder. These are the uprights here also, and one turn 90 here somewhere. I believe it's this one is the very top. Yes, that's a white 5 code daily van inside the pillar. Well, the van, good. So we're rotating. Sky shot. And you see our deck is in line, guys. This side of the deck, this is the one that they show in the video, that these people show in the video as the first collapse in the part of the video, which doesn't make sense to me because it can't make sense to me because we have the car inside there. If this collapsed first, how did the car get inside there? 2, if this collapsed first, why do we see the next clip? These guys just walking calmly, clearing themselves out of the rain. Not one guy, but 2 guys, another guy parking a vehicle in this direction. So this just collapsed and he starts driving in this direction? Yeah, you got to be pretty much non-believable. This did not collapse first. That video that these people released are some nasty shit, guys. You know the way I feel about that. Here are the Jersey barriers connected. Apparently Jersey barriers are still connected here, meaning they were anchored down, or they just stacked up behind each other. Okay, moving on. That's your data. They've already removed my section here at this point. Oh no, there it is. Right below here is the top bracing that comes across. This part right here, let me see if we got the guys with the arrow on it. This section here, guys, is, let me zoom out, tilt down. That section, if you can see where my laser is, it's from here coming over to this one. It's say about halfway across. There's a concrete. That is this section here. That's that. After spending a trillion hours looking at it, that's that section. All right, moving on. Oh, I just realized you guys didn't see it. It's down here. It's this section right here. It goes across. It's that, remember it? I look at compare it to new construction and old and the collapsed construction. Collapsed structure. There it is again. That's a recycle of the same image. Video rather. Not by me, but by them. And we're now recycling images, it appears. Let's fast forward. Now I did watch, they had a live view of this, guys. I watched every last 11-hour moment of it. I put it in fast forward and I didn't miss a damn thing. Alright, so this is where I showed you on the other bridge where the cables are exposed. These cables are not exposed, but very importantly, look at the details. This cabling detail is different than the next structure that they made because we have a gap between here. So the cable's high and low here, not filled solidly. The tendons are high and low. And let's go on. That's just data for you guys to evaluate. Oh, here's my baby. Here's my Bugs Bunny. There's Joe Rabbit. He says that's his car. If you look at the this part, I really thought about it, that he hit this, and then it went down there. I couldn't see any airbags. Somebody said curtain airbags. I couldn't see the airbag action. He's not a good witness. He's a great witness, but he doesn't recall a thing. Here's the other vehicle. Nosedived. This was obviously in front of that vehicle. Unless this guy drove over top of him after he went down and he kept going. I mean, he'd have to take the weight of this vehicle, figure out the angle of the bridge. Maybe it was collapsing. Maybe, he can't recall. That would be awesome to get that data from there to see how fast he was going when this came to termination. And as the one of the viewers stated, you can get that from the flight recorder, if you will, car recorder, if these newer systems have it. If this car's newer system has it. It's only a limited amount of time, 15 minutes or something. Okay, so this is just the ground trucks. We already went over these in other videos. No, nothing to be gathered there. And let me jump to there's our car. Let me jump to, again, this is in line. They're trying to get a sky shot. Give me a sky shot. So this is my first sky shot that I realized what I was looking at. And let me zoom in. That there's your line structure, and then this bridge is facing us. So it's like it took a 90-degree turn. But after looking at it in other images, it maybe took a 75-degree turn. It took this turn because right here was the column is still in place to help make that rotation. This puts the deck failure up. Okay, it's my mystery how all the water bottles. So let's go to another air shot, and that air shot will explain or show you the layout a little better. So here's the air shot here. An air shot again. That's the bottom bridge deck. Let me see if you guys can see that. Yeah. So this is that one that did the rotation. Here's our one side that's going straight down. Then we have the flip section here, and then we have the slightly. That's the top deck, slightly rotated section here. We're gonna get a better sky shot. Of course, you see that that's the nosedive. And here we go again. This tells you no failure took place here between this section and here. I know I'm repeating from other videos, but this helps people with their theories. This, for clarity, this is that connection. This is my fist, if you will, where I had my fist on that board. That would be that piece there for orientation purposes. And going on, I need to get a better sky shot. This is during demolition. They did so much doing that at that point. The data was getting corrupt. And Lemon. That's me saying, come on. Gave this a lot of thought. This was nothing, as I told you guys, as a fake repair. Here we go, sky shot. Here's our flip section. There's our car inside here. Here is these pieces right here. These are the braces. The windy weather is potentially cause for truck crash. But trucks crash on bridges all the time. Fires on bridges, everything. It's usually not catastrophic to cause a bridge to go. You can't take a bridge out normally with one hit. Based on history of vehicles crashing on bridges. Now you can see the rotation here of this structure here. No longer there. Rotate it, no on diagonal. This is that bump. I need to come up with a bump. Push this away. So this will get our bump will come from this side, not this side. This is our location, our distance, as it did that fulcrum action of these four uprights. And you saw that in the bridge that was demolition. And this would be roughly orientation in this case. And let's go to, great, we don't want to go to that, whatever that is. Another image. So we got the same thing going on, and this is the awesome data here, guys. I'll do that for my screenshot, because I like that for my screenshot. Now, let's go back to the bridgey right here now. You've got a lot of data. I think, let me look at my notes. See what I have here. Some of my notes. So we got dead load, creep, cables no longer supporting as they should, elongation took place. The thick wear layer, guys, do not discount the thick wear layer that's on that thing. It's 8 inches. That's so much dead load, guys. Seen from the center of the okay, yeah. Okay, let's do that center. Let's go back to the video. Let's have a little trolling fun first, breaking up the video a little bit, and it does count. Because this stuff gets traction, guys, and when it gets traction, sometimes you're fighting against, crap like this, and it's we're like those engineers or whatever somebody said the engineers said, more like a chain reaction, definitely chain reaction. So this guy, now let's see, it says 10,993 since I started this video. Let's see how many he did. I find it amazing. 14,000, guys. You just saw it pop. Since I started this video, this guy got 14,000 traction. Look, 222 people gave it a thumbs up. Awesome. But down below, he says, I'm looking for a witness. 2 replies. One of them is from me, I believe. Nope. Mine is deleted. Okay. I heard there are a few cases of people filming. Right. The only existing footage so far is the collapse shows the pillar collapsing. The main road already collapsed. A witness said that one of the cables broke. All right. So this person again, the only. We know it's more than that. All right. So this guy's getting traction on his multiple versions of this collapse. None of them show the flip section here, guys. Let's go ahead. We won't eat the whole video up. 5 minutes 21, but. This is this type of crap that I hate, this rendering, and he tells you, he gives it the rendering. So now he has the breaking of the cabling here. This automatically means that rotation, guys, has to come from this cable in his video. Remember, we also need this to shove over underneath this section here. This needs to come over. All right, so we just focusing on this alone. We run it. This totally breaks off. This is on the ground now. And we got a car sliding backwards, which is kind of cool, the rendering, right? We got a brake here, and I think I got to bump this up. Oh no, that's normal speed. And then he just has everything just collapsing down, centerpiece collapsing down. It turns into these blocks. There's the road deck on top. So this guy, to me, I don't even know him, but he's an ass. He's an ass. You know, when I see stuff like this, they just do it for their views. You know, I don't like the clickbait thing. You know, I don't like this fake stuff because they'll do anything. Like that guy, you guys follow him. Some of you do, I know. That guy in Canada, he's an ass too. You know, this is just craziness. Now, here's a second version of it, or another angle. Same thing. We got this coming down, it falls down, striking here, collapsing down. The same bridge, same thing, but now it's just a different rendering angle. So don't get confused thinking you're looking at 2 things. This is the same one. He just made up a fake camera angle. But again, this stuff gets traction because of jerks like that. Northeast cable failure, test number 2. Now this cable goes. Did anything change? No. Everything's the same thing, except for now he's got this hung up here. We have the blocks facing us now, the sections. And it's crumbled away from the bridge altogether, and you got asphalt here, center line. He has it collapsing straight down center line. This PFC has collapsing. There will be some houses down here. And no. So now he's doing a different angle. Again, it's the same stuff, guys. Different angles. Oh, there's the car. I do like the car falling like that. He's got the rocking action going. I really like his rocking action. Got a bus up here. Isn't that messed up? He put a bus up there. Now we know there's no bus there. He could have grabbed different rendering tools. Alright, so now he's got that collapsing. At the same time, he's got this side collapsing. Why the hell would this side start collapsing? Okay. Alright, so there's your crumbly thing. Now it's an imbalance, guys. If we can use this rendering. Now it's in an imbalance. So I'm going to steal part of his rendering here. Now it's an imbalance. You can see, as I described to you with my arms. Now this guy's taking a stress here. Tension on this side. Compression on this side. But we know that this then takes a rotation. Because it starts pulling across. If we can just look at it kind of differently. Those are 2 existing. So it starts taking a pulling on this side here. In the guy's video, it shows. It starts pulling. This guy's coming down. So this section here, backing up and slowing down. This section here, guys, will fall straight down pretty much. This is going to take action in this direction. This section, I think he has it going a different way, just collapsing straight down, which is, there's no debris there. These guys land on top. Oh, he didn't finish it. Sure. So, he's got two cables. 2 cables failed. 2 cables failed at this point. Here, just failed. And that falls, different angle. Now we got this cable swinging over, and we're back to this thing going like this. We're looking at him because we need a car to fly off of here because this is the closest he came. Look, guys, we got a flipping here. He came very, very close there. Then he's going to turn it into junk. And he piled everything on top of here, which wasn't like that. So now he just blew it. And then this this is not like this. We know this to be standing up. We know this to be turning in a different direction. But asses like this get 15,000 hits, and that means 15,000 people are taking it on as data. And I think we'll terminate this video at this point. Yeah. You don't show, agree, guys. You don't show the flipping, you're not doing it. Look, now, I said that as structure in the beginning of the video, I said, no, it should stand. It's similar to these. Now, this is where I would discount my own statement. See the setup, guys? That's a different setup than this setup of all these tension cables. I need coffee. Hermit needs coffee. Shit, I need something to drink, too. That's a different setup. As you see with the cabling, it's like forked. Let's run the video, and we already know this anyway, but here's ID1, whatever they titled this. And some people told me that, no, people don't have timestamp on security cameras. Well, obviously you don't own a security camera. Every security camera has a timestamp on it. If you don't put it on there, you defeat the damn purpose. Everyone keeps this. You can possibly take the timestamp off. No one does that. That's just ridiculous. All right, so there's no timestamp on here, meaning the video is larger than it appears. Now, we have the vehicle leaving, and they have this side collapsing first, okay, in this video. Guys leaving. So if this side's collapsing first, we know now that the other side could not have collapsed at this point. This guy is still, having a merry-go time, and you don't see any debris flying across, at least in the video. But I'm already saying it's collapsed on the other side first, not this side. But we'll go with this. Go with this data, and I'll try to make it work. Flying out. Rick. Okay, so yeah, I agree. And everybody's telling me do a computer model. I've got Q engineers writing, do a computer model. I'm like, do my balls. Look, all right, so look, we know now that this back end didn't fall first because we see this literally deteriorating from this point back. So it had an impact further out, and now this tells you at this point the angle of the bridge, which means you already, and now it's just crumbling backwards, falling backwards. So you can figure out, based on this length, where it took an impact, plus the impact of the ground, and you can put all this back and see the cantilever of this. If I knew the length, like I did with the other bridge guys, if I knew the length of those members, and I knew the length of this impact and all that, I could reenact this 100% on how this had to fail at where the break could happen. Because remember how I made the 1-to-1 scale, close to 1-to-1 scale, that it can't reach, it can't just reach, right? No more than I can make my arm reach any further than it can. Neither can this stuff. So it will show if something broke or not. And we have no cantilever here, guys. No cantilever. This is just no flip rather. Yet we've got symmetrical bridges. The bridge, so therefore we're showing it. Now, based on their video, they're leading on that the other side collapsed first. Sharing with Gordon and everybody else about video images, this piece of concrete you can find online. And if you triangulate this view, you would be in the middle of the damn street or in a pole sticking across the street, which I couldn't find. But you can see the angle. I would need to know this camera, and we can determine field of view, FOV, and we could figure out what's going on here as far as how much they cropped. And then you'd figure out and you just extrapolate a larger image and go from there. But here it is. The other side of the bridge fell first. These guys just having a merry-go time about it. Walking over. La 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 la. La la la. Rain. One guy. It's going to come number 2. We got a guy that's going to be parking. There we go. I found other videos. This guy parks here all the time. Or this vehicle is parked here all the time. I found back in time you can find vehicles parked there. We see that guy go towards the collapsed bridge. Of course he did not. That's the collapsed structure. This goes underneath of that. This point we're going underneath of the bridge structure above us. Okay, moving on. We got guy number 2 coming around. So we know he didn't come around with a broom and a shovel, whatever it is. So the bridge is not collapsed on the other side yet. And he's got his bag protecting him, and he's worried about rain. There is no falling of any damn bridge on the other side at this point. But yet they did this video in this sequence, and I'm like everybody else. I don't like it. Now we got a bridge collapsing. We do not have members collapsing here first. You see it come from right to left. Right to left, not straight down. Not straight down. Right to left. And we know the orientation. And we don't know what's been clipped out of this and edited, because next thing you know we see a cat and we see a man running across and behind the grassy knoll. Right here comes the grassy knoll man. Oh, it's a Sasquatch. You guys see the Sasquatch? I had to make fun. I wanted to do that the other day too. The guy running. I'll do it one more time. Watch the Sasquatch, guys. Right there, here it comes. Runs across, the Sasquatch takes off. Yo, he's got a bag. It's one of the workers with the yellow bags. So then we got, and I love this part. My favorite part is when in this part of the video is the cat. They clear up the video. And all within these few seconds, supposedly a cat ran across 50 foot of debris or 40 foot of debris. And there comes the kitty cat. Now, that doesn't make amygdala sense. Alright, so we got that video in there, and you guys see the shape, see that angle, you know where to find that. Yeah, Jeff, they're trying to, the other one, they're trying to make out like the other one fell first. Well, at least in their video, they're rendering. But maybe they're that ignorant that they don't even know what they're looking at, and they can't pretend, and they don't know how to read a timestamp. You know what I'm saying there, buddies? You can't read a timestamp? Well, and then you could calculate whether, if the device still works, you could see how off they might be. Each one might be timestamped incorrectly, but you could determine that. And then adjust for it. The timestamp's going to tell us everything. But there's no way in hell that the right side fell first. This side fell first. We see the guy filming, and by then the left side's already gone. But I'll leave it open for you guys to have your own fun on it. I'll leave you guys on. And this one, we found that one on the building. And then there's another camera over here facing more downwards that they have not shown a video of. The one over here, guys. There's 2 of them on this corner over here. Corner over here. There's 2 of them on the building. They haven't. One is facing away, but hell, it might get a reflection off a car. So show it. It might show somebody slamming on brakes, seeing the fucking bridge collapse, and that would give you an indication of what's going on. You know, this road is pretty busy. All of a sudden, not a single witness saw the damn bridge collapse from down below. I find that amazing. All these people driving, missing the bridge collapse, just barely, and not one able to say, I saw the damn thing fall. I mean, I know Italians are rough as hell because I see fences everywhere. When you guys went looking for cameras with me, Gordon, we saw block walls everywhere. No wonder they didn't need cameras. But really, you don't even speak up when you're running into a bridge? All right, so again, this structure is different here, guys. We don't have the barriers. We have a different setup here. And let's roll right into putting the data for you at this guy. I'm gonna zoom. I'm gonna check my battery power. It is at. Oh, we're going out of this video. We won't make it. We're not gonna make it. Let me see what's going on here. If I can get a little more charging action going on. I'm thinking my charger is failed. Let me grab a different charger plug. Justin, I'm ready to finish it off. Laugh out loud, right? Ho, 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 ho. That phone's going to shut down too. It might shut down during this video. Let me hurry up. Maybe you'll get lucky. Because it has a certain percentage it will shut off. Let me see. It says charging. I'm at 9%. This might jump on us any minute. And I've got the thing way down, guys. You know what? I can just turn off the screen fully. And I'll just zoom out. And hopefully this will be enough. And we got a little bit more. Good. I'm going to shut the screen off. Well, suppose it looks like at 11%. I think I won't rock the boat. All right, Jeff. Take care, Jeff. All right, let's do it. All right, so that's what happened. All right, test, test, test. Testing, testing. 20 seconds in the hole. Come on, thing. Let me see. All right. All right, so I only have a limited amount of time, it looks like, on this thing. I can't change batteries. It's stuck. So let's hurry this up and try to get this figured out. Got plan B. Doesn't like the heat. Okay. We'll remove these cars. Keep rubber ducky. Keep whatever that is. Nope. We'll take this tension member out. You guys still hear me, I hope. Yep. Let me cut this line. Okay, so put the tension into this guy here. That's your cabling, right? Give me a second, I'm just grabbing some more cabling real quickly. Come on, don't die on me, baby. I'm not saying this is enough. Let's see if we get lucky. Yes. Okay, this one across the top. Let's come down. Okay. We have our setup. Let me get you a better image, better video of it. Better video. Gotta wait a few seconds for you guys to catch up to it. Give me a second. Okay, here we go. I'm going to turn it a little more. It takes like 20 seconds, guys. Catch up. Okay, you're caught up. And then you gotta wait 20 seconds for me to catch you guys up. So, you take your pick. We got Jersey barriers causing the strain, right? We got a joint here that we can release at any time we want. Let's go ahead and release it now. Well, that would be stupid because that's not the way it happens, so I won't release it now. Let's do, you pick the failure with this nice system. So you can pick a failure here and you've got nothing going on. You've got this piece flapping off and dying on its own, just breaking at an expansion joint. And it's dead. Nothing happened. No harm, no foul. Cars fall down here. The system's still imbalanced from here over to here. It's still balanced. So you're eliminating this end here. Not an issue. You do the same on the other end. Not an issue. You eliminate all the way up to here. Got a slight imbalance, but you need a way to break that in there. With that said, there is a video where I show the video where the bridge deck does have cracks in it. I think it was in that section over there where I found that in the span as the Google was going down the road, you could see in the asphalt a huge, maybe 2-inch crack across it, which would indicate that the subsurface below the asphalt layer, let's call this the asphalt layer, that the subsurface down here opened up approximately 2 inches to allow that 2 inches of asphalt to open up and reveal itself, which is really 2-inch gap rather, which is really 8 inches of asphalt, which is huge, the amount of load on that. You also have in the structure the road going up and down. If you go in that one video that I found where you're watching the car and I paused it, the original video, the first one I did, we were in the car and I paused and said, wait a minute, look at that deck, it goes up and down. So that's showing creep. You try to find out where that creep is. My guess is, and I have to look at the video again, back down at this point again. This is the part that's asphalt decking. That's I don't know where these are on the ground. These guys here, these two connections. This is the part that rotated. Two parts rotated. A section stayed on here and under that side, under the side of the bridge is existing. And then the other section is parallel. It's not in line. It's diagonal to it to the road deck. And we know that's on the other side also. This is the white. I think it's like white and yellow. And that's down there. Then this guy sitting on top of upper level, on top of it. The train tracks up here. The other collapse with the car inside of it. On the other side, we have the same thing going on, similar, but let's just work with this side as the beginning of the collapse. And so if we take this out, I'm waiting for the camera to catch up. I guess I shouldn't look at that. If we remove this, we still get the structure being held up with a cantilever, with this being held from here to here. You can't remove it because there is no failure in it. It doesn't show like it's failing. There's no, I don't know if there's any buckling, but you would have to show all 4 points failing, or at least show one of them failing, showing that it was taking on more load. Say the outside one, say this got loose, and that would put more load on this guy here to the left. The problem I have with you showing anything besides symmetry and the failure of that is that would create a torque, a rotation, right? And yet we have the thing collapsed on the ground 1-to-1 almost, just a total flip over like you saw of that demolition shot. We don't have a rotation failure buckling like that, and then the thing fell down and it's on its side. We have it like that. We got rubber ducky inside of it. So we don't really have, we can't really point at this guy at these unless it was demolition. We can't point it at them individually as an issue. All 4 would have to collapse equally. And to do that, they'd have to have a load on them. And the load would be dead traffic, the bridge load, etc. But then that would create a sag in here that would have been revealed. And this would have been the lower part. The sag would be down here. This would be falling first. The cable, this is the cable, and this is the sag. Well, then that would fall first, and you see what happened. My arm is holding. I would be coming back into there. And that's, along with this guy in the way. I'd be working my way back to here or to here, because this would still be maintaining connection. So we can't really point to the center for that. To make this thing flip, to have this part of the section flip, it goes back to here to we have in the collapse, you have the area down below, pretty much all free of the debris minus these columns are sitting on top of it. So we have the collapse happening in 2 stages, one on that side and one off to the side and then down. This is the one where we see it's leaning up against the brace down the bottom. So both of them went that way, but this one went that way a little bit and down. The secondary collapse. This worked with the primary collapse on this side of the structure. For this to be a primary collapse and get those rotations, that's very important, and get rubber ducky here, which is very important. Very sharp. So anyway, to get rubber ducky there, this guy has to still be in place, the right side. Because you can't get rubber ducky down there. Can you guys get rubber ducky here? Rubber ducky's on top of the bridge. He goes, as this falls down, rubber ducky goes into the air, but not in that direction anymore. Rubber ducky just happens to go into the air, straight up into the air, and then down even further. So I don't get rubber ducky being catapulted and falling and falling and falling and falling into the structure still. I don't get that. I don't know if you guys don't get it either, but there's rubber ducky. And I see a comment, consideration of the pillar where the road deck is resting on. So I've really looked at the road deck, if this is what Alpine is talking about. It's braces here, but there are 2 of them inside here, one here and one here. And I went underneath that deck with Google and I looked up there, and I think I saw daylight on one side, one end of it. If I saw daylight on one end, I'm assuming that's not an arc design. So I'm assuming that it's just a brace, like a brace across the top. And that each one was designed just like this ladder, like these rungs, to act as a brace only, but not load bearing as I have it here. That they did some load bearing, and that's where I'm going to show you the break somewhere in it, and I can't find it, guys, a connection here. So this is where, a connection here is where they did some, this connection is very important. But I can't cause a bridge to collapse by breaking it here initially. If I break it here initially, I'd get an even break, even collapse both directions, maybe both of them cantilevering, both of them at the same time. That both, since it's down the middle, let's call it, they both want to do that. That would get this section here. Let's see if I can do this right. So here's an expansion joint. That would do this, right? As this end came up, as you put a load here, the vehicles, this would do that. This would bring this up. It starts it going. But you create a piano hinge in here, right? It would look like I don't want to mess this up. Let me grab a different one. I was getting to that with that one too. So both of them together. Where's my other piece? Oh, it's over there in the other bridge. So as the cars go on it, you know, you'd have a little bit of flexing going on. Let's see if you guys can see it. Yeah. You'd have that little bit of flexing going on. I'm getting distracted by my own video in the background. Okay. I have to remember what I was thinking too. So here we go. So if this was here, I still have these in place. So as you put a load, I'm trying to figure out how to visualize it. As you put a load here, it's here. This would create a negative load here, going down. So not much. It's car traffic. If we have this point here that's actually resting, well then it's a little less of a cantilever if it's resting there at that point. So that little bit of overhang is insignificant. Your failure would be more localized. It would still be supported from here to here. So I could show you that, but I don't want to show it yet. I can cut out a section of this, and the structure would want to compress. So I can't really cut out a section. We don't have any debris down here to justify cutting out a section and making it fall. There is no debris present down there. So I'm not justified in making a failure, pulling out part of the deck and making it fall down. It's sort of like that guy's video, just making a finished data. I can't do that. But if I could do it, it would still, the loads would still be out from that, it would drop down that few inches or maybe whatever it is, the contact point. And it would still maintain a balanced load on each side, albeit it's going down to the ground ultimately. So I don't have a failure, the initial failure there. We will get a failure there though if I create a failure here. If this is the left side of the bridge, as I'm calling it, the start initiation. I need to get rotation. I can't have a failure past it because I don't get any rotation. Remember guys, I'll just get an even fall down. And also the structure would probably hold up. As we saw in the demolition, they blew one side of it and you saw the center section with the two cantilevers holding up strongly. And it had none of this going on. It just had these braces going on. It had this going on with no extra no redundancy, not these guys, just that. But they were limited in their overhang. This extra overhang creates that cantilever effect and a negative load to the point of this. So if this is the center, we'll use this as center, and that's the outer section, and we'll use that as our point. If I put it in the middle, balancing it, well, I'm pretty much stuck in the middle, right? I'm not going anywhere. But proportionally, if I put it with a bigger cantilever, you see what's happening there already. It's using its own dead weight working against this structure that these cables right here have to always maintain to stop that dead weight. Or you get the flip. You will get the flip every time out. Let's see it come up to here, guys. Here's your flip, and I'm at a short distance, but you get your flip. And then you get Bugs Bunny coming over here, landing on it, and that's it. So how do we get there? We need rotation, so cable's got to come off. Cable's got it. We have to have failure. And this is where I have my failure. Let's work that out now. Because I told you my rotation, I can sort of make it happen. Because I don't know which direction this bridge is. If I cut this one first and I leave this one, as this goes down, I still get a rotation. But it seems like if I leave the connecting point there, the cable, it seems like if I pull on this one here, say pulling on this point here, that I create this effect. Look. That gives me a turnout. Doesn't that give me the turnout that we're talking about, the hinge? That gives me a turnout underneath the structure, a rotation, and a lay down. So it would seem like this would be the one that would give me my first start of my failure, the outer one. Now, if I put the failure here, this is the last one holding rather, and the failure's gone, and this one's missing, and the failure, and I'm able to hold on to this one to get my rotation, I get a turnout still. But look what happened. I'm holding here last. I do a separation, but look at my bridge. It seems like it turns that direction. I'm only turning from this point. Now to illustrate that better without contaminating it with my hand, hopefully you guys can see. Let's move there. Then if I pull this direction, just from the corner, I start to get my turn that direction. I need a bump though, to bump under, to go underneath that structure. So let's create no movement here yet. I need it, this can stay hinged. But you see what happens, guys? This is what I showed you about the cardboard images. If I start my rotation in the air right now, what happens? I'm binding it right here. It's binding there. We don't have that damage to show any binding. Binding, B-I-N-D-I-N-G, binding. We don't have any binding there. So we don't have the rotation while this is still connected. We don't see this debris, like we don't see this compressed up here, and we don't see it compressed down there. We sort of get this break, we get this falling away, then we get the rotation. Because we don't see failure up here on this side or that side. So to get it, we need to fall away first. Then we can start our rotation. But I can almost get it to work from either angle, right? I can get it to work from almost either angle. And as this rotation falls downward, this would break free, of course, from the joint above. So we need to get it to go down. This gives me my downward motion. I shift it in my mind each time. So now we actually do some cutting now. So let's cut. This starts to fail. We'll leave that for flex, the tape. So I made a cut through it. Hey Scott, we're wrapping it up, man. You're coming in, or you've been there for a while? So I'm just going to cover my crack, just so hopefully it's strong enough to cover, so I can get a flex out of it. So you see what I did? I cut it first, and then I'm taping over the cut. It gives me a hinge. So that, remember, we have a history of the cracks that I showed. So I can put a crack anywhere I want based on that history. And what you get? You get this all of a sudden loosening up when that starts going down, right? But we get this releasing here. We have the counter load of the other side just went into tension more. So this guy's more in tension. This actually got more relaxed, creating compression against here now. This is what I'd like to see on the ground. I'd like to find that compressive points where this took place. If this is going down, we now have a release. We'll remove the barriers for just posterity, right? Just for reasons here. But now we have a release. And at this point, we got another expansion joint somewhere down here. It might have been off to the right a little bit more. I doubt it. I think it's more this way. And I think I have this off, totally off. This brace. This needs to be back more. This is too balanced now. Hey, it's so balanced I don't think it'll go anywhere. This is way too balanced. I'd have to have it up there like that. Rubber ducky. Rubber Ducky's an amazing one. He's got to do some flight time to get over there. That's the one I find so amazing. But now you see I don't get a binding here, so now we know we saw no binding there, right? We now get this thing doing this. And listen, I got to look at my mock-up, see how that went. So the cut was give me a second. I got to see my cut again. Oh, okay. Right, it's going over, that's where it is at the brace. So then I have a cut, let's just call that rough. I wish I had a real scale of everything, because then I could scale it, right? The angles and all that stuff. Let's do that. Sorry, Ducky, you gotta go. Now look, what I just did there was cause, let me let this go. We have a full break inside here. It's a full cut. We got Rubber Ducky coming around the turn. See what happened there? You see that shove? What happened was the loads transferred over. It pushed it over because it's no longer in balance. Stay. It's no longer in balance. We have this going down. This side of the structure wants to shove that. That's part of my shove also, my balance. Because I need this decking to go over and under. Remember, I need a bounce, a hit to it. I need a force. And now we just created a force with this guy giving a little shove. At the same time, probably going up in the air, also dropping down on the far right. This one down here is going down, ultimately to break free and turn standing up in the angle. So now we have this going on. We need failure. This can't, remember guys, this is not going to go any further than it's going to go. It's maxing out. You're not going to elongate this all the way down to the ground. So if it's already weak, the deck failure is here. This can no longer take it. We can release one of them. Let's release this one. Let's release it right there. We can release one or the other, but we released it. Now we have we released it to the point where we can't hold anymore. I could leave some strands on it, tendons. Ultimately, it totally comes off. Now you see what happens is the deck decelerates even more. We've got my tape holding it there. I'll release the tape. At the same time, Rubber Ducky's got to start working his way down the road here to come out. Let me see if I can get you a better. I guess I can't. I think the road deck is what's going on here. So now we have another expansion joint here, but that needs to break free and go that way. But for this video, maybe I won't put the expansion in it, and maybe I should. I can't show both at the same time. I'm going to have to sacrifice doing it 2 stages here. So let's break this. This is done. This is done. This now starts coming off. I'll put that brace back. Starts coming off. This gets shoved over. And now remember we got the cantilever effect. But right now we're still stuck here with this guy here. It does its rotation. I'll put that back. It does a shove as the back part of the bridge, as it's going down. It does a shove, a quick little bounce. That bounce puts it in orientation underneath the train tracks in that slight angle. Not like this, but in a slight angle. So now we have the slight angle. We need this to do a turn also, because it's not lined up that way. It's on the ground, on the dirt, like this. It's maybe like that angle, but it's not in line. So this is still holding on. This cable's still holding on as this tries to decelerate. It can't hold any longer. It gets free. It then falls to the ground in that diagonal shape, in that angle shape. We have this decking falling. So we're there. We're still braced, but we're off. The cantilever is off. So that decking's falling over. This actually breaks the other way. Breaks the other direction. So this, did I just mess up top of this? Yep. So I can't, I've got to show the breakage. So I wish I could show it with the other piece. But this guy still in place, as I showed you with the explosive video, the explosions. Does a rotation. And we got rubber ducky guy. I think this bridge is still in place at this point. Maybe it's out to here, guys. Maybe it's that far over. I don't know where that joint breaks. But I could figure it out based on how much the debris is. Rubber ducky comes flying off of his bridge. That's the football player. And he winds up inside. And he winds up inside the underside of that flip. And then what, the number 2 or number 3, third bay over. This guy still is still trying to hold on. Watch what happens when I let go. See what happens when I let go? Let's do that again. It's the force that pushed it that way also, that little nudge I needed for the opposite end. And you can see the orientation of where this is going straight down, diving to the ground, and start piling up. I'm waiting for the video to catch up. So, what do we have? I know you guys take a second to catch up. Now we have, let me push this down. We have that rotation. We have a section down here, expansion joint. So we have an expansion joint here also. That's the part that's going to rotate and break. So as I showed you that, it wants to push back. At some point, it breaks free. The expansion joint breaks free, and now you see what happens? The load transfers and starts coming in this direction. But the cables are still connected, and we lose this cable first. Number I need this cable to be intact, guys. It's got to pull on that one first. So as it starts falling, in that video, as it starts to fall, I got tension on this now. I need tension on this. I need tension on the outer cables. So this cable still has to be tensioned. It still has to be taking a load. Okay. It's got to be taking a load, guys. I'll explain in a minute. Get back. It's got to be taking a load. And I'll explain in a minute why this side was still intact. That it was set. You'll visualize. You'll see it in a second. It's not balanced. They're not on purpose, just on accident. So, so this guy, you saw it do that, but then now the expansion joint can't hold, so it starts going down like that. If this guy starts coming down, this is the part that rests. We have another expansion joint here somewhere that it also allows for the failure. This, as it's going down, it starts pulling on I need this intact. I can't make this one fail first. If I fail this one first, I don't get the rotation of this decking. This is the outer hand, and the decking it's in this direction here, guys. we have a video showing that it's pulling, the top is being pulled over. The top of these, the pop's being pulled over by the outer one, not by this one. So it needs to still put a force up there, pulling it down. And that would be this one. So as it's pulling, it's going down. It's now pulling on that guy there. I think it releases here, but the load's already started as drama up there where that's now wanting to fall down and is pulling on that side. It breaks free. It breaks free. It's going to ultimately land on top of this decking here. This outer one's going to land here, the L shape. This starts to fall down. See the binding here, guys? See the binding is happening here? It's still a joint. It's still a joint. It's binding. It does that rotation as this is pushing down. Watch how I do that rotation again. So it's falling. It's pushing it away. As it's pushing it away, this one now breaks free somewhere about there. Breaking. Shit. Can you guys see it? I'm going to go up higher on it. I got to go up higher to show you the same thing. I was getting too low, wasn't I? Let's do a little closer. Next. So as it starts falling down, I think that's going to be you guys to see it. As it starts falling down, I guess I should be further out than that, right? As it starts falling down, pushing on this guy, you see it's rotating it? That joint is what I'm trying to get you to see. Right there. Push away. I'm trying to get you to see right there. And I don't like that. Let me get some more slack. Okay, we need that rotation on this. So we're back to this again. So as it's going down, this is still connected at this joint here. And it's going to break at this point after it finishes off its rotation and it can't elongate anymore. So this guy was probably still pushing on it to some degree because it needs to be enough force on it to sever it and not just swing it back over like a swing, because that cable was not that length where it would swing it over to the bottom. It had to break in midair, and so the forces had to be so great. But this did it, and it caused this rotation. Remember, it's like that. Broke free, and it went flying down to the ground and buried itself in there. That cable then broke, of course, at that point. So that's in the ground there. Now we have this guy coming down. Expansion joint breaks free, I think, somewhere up there too. It does its break. Now we got some decking down here, maybe a tractor trailer or something like that there. This guy slides down. We see the video where it hits here and then crumbles down and rests on top of the piers right about here with some of this sticking up. Look at that video. So look, Gordon just reminded me. That's what I said in the. I'm glad Gordon did that. Gordon said that, yeah, as it was taking a force, it did go outwards to some degree, and then it righted itself back over. It did have an outward rotation. Now I think I said that in, I don't know, my third videos or something, and on a third video, but near the end it would have given it that shove, that put that outward force. But that still gets us there. Hey, anybody want some hot glue? Let's see what else you got. See what else you have before we wrap it up. So let's talk about Sandu's comments. Sandu said he's not sure if that was the Fuchs failure. Well, I can't. I'm not even going to discuss whether it was on the right side first. That's not even open to me. If you think it was on the right side, we're not even on the same page. Because I can't get over to that page unless you demolitioned it. I can't get there. But the right side, the other side, if you were to, there's the structure. If you were to, you could take your pick on the failure, but it's not going to work out. You won't get the failure mechanisms to do the pad. If you cut a cable, well, look at it right now. I have nothing on there, but and I left out the other braces. So you got a brace here, a cantilever. The cantilever would be flexing there. So this would be counteracting that flex. Yeah, this is counteracting that flex. The cantilever, the cabling is. I'm going to bring it up in the air to show you, to help you render it a little better in your mind. So, this is in the air. Now look what happens when I make a cable fail on one side. On that side there. If it fails on one side, it's going to fail on both sides. You get this rotation going on, but let's be more fair. Let's put it on. Oops. Take your pick. You got supports here. You have supports here helping with the cantilever. You cut one of them, you still get a rotation. You get a dip in the deck. You get a dip in the deck with the turning, but the failure, you don't have this failing. How do you get this to fail back here now? You've got the whole thing flipping over now. If you cut one of them only. The deck gives you the rotation on both ends. It gives you the mechanism to get the two ends rotating to shove off. I cut this. I don't get this rotating and breaking, and I don't know if I get the flipping, but I don't get the. I will not get the. I get a deck that falls over one side. You get a deck falling one side. I get the other mechanism going, and you get the shoving you get the explanation of the vehicle. I don't get vehicles resting on top of there. I get all the vehicles off to one side if I do that. I don't get them all there because I didn't do it all, run it all 100% that way. But I get vehicles off to one side, and we do have the collapse on the back side. The vehicles, all the collapse is back to the right, this direction. It's on the right side. It's going that direction. On this side, we have multiple things going on. We have a flip deck, isolated flip deck area. We got a rotation deck this way, closer to the bridge. And then on the opposite side of the bridge, we have another section of deck in that direction and that way. I get a broken deck here. I get everything sort of failing. Well, if you put it on the other side, I get everything failing, and I got no action going this way and that way. Yeah, so Gordon, it did have that pushing effect. As we need we need some force, a pushing effect, to push it out. Whether it was this section, as I showed, as it goes to flip over, slide off, it shoved it. We have it collapsing in 2 stages, because if we collapse it all at once, we'd have in the center of the structure, we would have debris, but we don't have the debris like that. We have the pylons. We got a car inside the center of the structure, being you saw it being removed, and the debris on the ground, practically none in the center. It's off each end, so we have it breaking. We definitely have it breaking in the middle, going 2 directions. We've got that other brace here. Remember, guys, you saw the demo part that goes there. Let's look at your comments, see what else you might want to run down. What line do you want to run down before of attack on that? Let's see. About the window, you cut the cables close to the window. Sure, the right side of the bridge, which is gone on the Oh God video. What Oh God video? It would also have. Well, Sandy, you still need a pushing moment. You still need pushing in your description. In your description, you still need to shove and rotation on 2 ends. On 2 ends. So you want to cut one cable. You're leaving out. You're just cutting the cable. You're leaving out the expansion joints that they have to start heading down towards the ground, and at that point they have to change directions. We have multiple changes of directions here. Yeah, Alpine, I don't know. I told you I looked in the video. It's very hard when I looked at the Google. It's very hard to see if anything's supporting there. But as I looked up, there seemed to be some daylight on one end of it, like I said, like an arc. I would think that something's braced there, that in English, that they did not use 2 cantilevers. That is, if it was just freestanding like that, then the only point supporting is here, and the other one here, and then that's a free span from here to here. The unsupported span is from here to here, making it like a girder in between it. I don't see that. I didn't see that. I love this. That's why I was trolling the other videos, the other images of this bridge style, and nobody's gone down there to look at it like that. And they don't want to find anything. They're running reports now on those bridges, and nothing's coming up shared on public line. I mean, we definitely have cables breaking. All right, so you want to break the cable here. At what point do you want to break the cable? You got to tell me. You're breaking in the middle. You're breaking at the connections. If you're breaking at the connections, I need to see the connection on the ground. You're going to get a rotation out there. Remember I said these two I can make it rotate. You can pick your choice on this one. I said on either one of these that fell first, and I can get it to rotate. But you're saying no brake here, and as soon as you do that to me, I got the thing rotating. I've got it rotating, and I no longer have a proper flip. So we know that it's on the brace here. So let's put that brace in. Let's play with sand here. So that brace is here. That's connected, concreted in. So I cut this. I elongated it a little bit. What did I do? I want to put that back on the damn support. All right, so it's back on the support. You had me destroy a cable. What did I do? I'll tell you what I did, but what did I do? What do you think I did? The unsupported section is from here to here, but this cable is no longer effective as you have a load that somehow isolated this cable, which I'm not being smart. It isolated this cable and it made it release. You also, being connected at the top, at the shoulder, you put stress on the other side of the connection here. But we release it. You've got the load releasing there. How did you break it? How did you break all the strands in there? You saw it was a bundle of strands, and it appeared to have two sets separately. How did you break both of them? You give me a break here, and I break both of these one at a time, however you want to. You want to break this. That joint is got redundancy in that it has a lot of cables, and it had a fork. If you look at it, it's fork design. It's like it's fork design. It looks like joint looks like so here's the joint, right? Let's call that's the joint. And it had this design like this, or has, or whatever, like this. The other ones at the other bridge structure had cabling exposed, and it's everywhere in here, but this one has a void here. So this is kind of redundant. You've got to kill both sides. How do you get both of them? Well, nefarious means you could have this one not already failed a long time ago, and they were just laying on this one. I mean, that's possible with the way they're talking all the time. But how did you get it? How did you get this entire thing to fail? You can get it to fail at the connection, that this whole thing would just shear off. So the load would have to have a hell of a torque. I mean, a movement. The movement to sever that beyond elongation would be a hell of a lot of movement over there. That deck would be like, you know, I don't know what it would be like. I don't know how long that would elongate before it would fail. Before you would not see it, if you can follow that. But if you get the deck to fail, you can get everything all at once. You can get your collapse all at once. This one would take a blind person, multiple blind people, not to see that the bridge is creeped down that far. And the joint would have to fail catastrophically. I mean, dramatically. Then I wouldn't get my rotation. Would I get my rotation? So this goes. This is here. I don't get the rest of the failing. I got you showed it broke. I got this possibly taking on a load. Maybe it breaks it at the joint here. Then it starts to rotate. But I don't get the elongation it would take. That would take so much to that joint to fail. And we have a history of this bridge, those joints not failing at this connection or the other one because of the rotation being so great. You'd have to find me an image to show me this joint fail. I don't see these two elongating enough where people wouldn't just get off the bridge common sense wise going, You gotta be shitting me. I'm not going on a bridge just doing this at that one connection. I don't see that. I tried. Ah, I like that, guys. Looks like it worked. It actually let me, all I did was say go live again. All I did was say go live again. All I did was say go live again. Well, that's the end of that anyway, though, isn't it? We can play around with a few things. You can't really get it to break at the top to do to any real means. You get elongation, you get creep, but if you get deck failure, you can get behind the cables. You can get this thing to collapse. You get deck failure in front of the cables, it just stands pretty pat. And that's that design I was referring to. That you can see the current design. The updated design, if you will, is much better. There's that major rotation I'm talking about. And the one you said cut closer to the window, I think would be, well, now, on this end, it would be opposite the window. On the other end to get that rotation. It wouldn't have been under here. That means the break would have taken place down here if I don't see the cables, or up top. And at that point, this is the guy videotaping at this point, when he saw it pulling that thing over, pulling the piers over. This top section is this side over here. That would be doing the pulling, the rotation at this point. Be encased in concrete, the fence, for example. Right, they don't have to be encased in concrete. That was sort of them thinking it was going to be long term. No water would get to it, it would just repair. But you created creep on the cables, you created a load on the cables that worked over all these years also. But they obviously knew that the cables were an issue, because they gave it extra support exactly on those cables and on the first structure. So we can, we can reach for that. The cables are, and you could also argue that, well, they checked the other ones and there were no issue at that time. So you got to catch 22 there. Common sense would say reinforce them all, but maybe they explored it at that point and said, we can't do anything better than what's here at this point. Yeah, I just said it. I just said it, Alpine. Okay. Again, for protection. Encasing concrete is going to be protection against the elements. And there we have it as that side there pulling down and straight down, and the other side flipping. And we see where we get the flippy. How we get the flipping. I want to find that video again. You're not going to find my porn in this video. I made sure to delete my porn history in case somebody pauses and tries to see where I'm going. So that's not happening. My porn is private. Is this the one? Oh, here it is. I think it's this one, right? Yeah. I think encasing the cables in concrete is cosmetic. It was designed for that protection, not for cosmetics. Alright, here's that collapse again, guys, for people who missed it. For you peeps that missed it. So this is not a collapse, this is a demo. Let me zoom in. So what's going to happen here, let me explain. Pausing it. Oh, that's a cut in. Those are like blast blankets right there. They're going to protect the debris from flying out, so don't think you're reading anything. This weakened the structure on purpose. You can see that they cut away the concrete to help make the sever of these two sections. This is a center design. This is without the piers, pylons, if you will. There are the uprights. And now we're going to watch this section to the left. It's going to do a beautiful flip, what we need to see. And let's get to it. That's them obviously zooming out, showing the structure all the way down to the base. We have the 4 supports. We do have dynamite placed, I believe, here, where they got into it. Here, here, and here. I don't think they did any extra weakening of that structure there, but perhaps you can see also. I find it weird as by their nature stays will flex. Concrete hates flexion. Exactly, I think the same, Sandy. You should not be putting concrete in a flexural position. But they've got all types of people telling you now that, oh, our concrete has a very flexural. Jumping forward, and we're going to watch. So they already did start the blow up. I paused the video. You can see where they're taking out a section of bridge. When they remove this section, this does not collapse on its own, even though it's already been weakened. And it just took a traumatic event. An explosion took place right next to it. And as I pause there, and it's pulling away. Until they detonate this thing is standing pat. So I'm showing you the two ends did not initiate this collapse based on this. Also, this cantilever is different. This is a lot less of a cantilever, if you will, guys. Look at this. This overhang before you reach the cables, a lot less. We're still going to get that rotation because as this tries to fall, this is going to help it with this cantilever action, and it's going to get an amazingly fast rotation, which I find beautiful. We're flipping, if you will. So now we lost that structure, and this thing is not exhibiting any signs of failure because this traumatic explosion just took place on the bridge. The car accident, if you will. Somebody said a blowing up of a truck. Well, here's a blowing up of a section of structure, a bridge next to it. Moving on. And now that's cleared. Now we start this. I think they started the base, perhaps. I don't recall. But nevertheless, you're going to watch. Yeah, I think they started the base. And then now we're going to blow 1 and 2. This section is blown first, obviously, and then this section, evidently. And there we go. And now we blew the base. Bottom, other side of that gets blown. We carry on, and I do not see a secondary blow here, guys. No secondary blow, and yet we're going to see a beautiful, not just a straight fall, gravity straight down. We're going to get a rotation as this tries to go down. It hits a bit of a shelf, I think. And we also get our secondary break here, which we do have on the existing deck. Bridge, flip, and that's where that car winds up. Here comes the beautiful flip. Beautiful flip. And there's your secondary break on the column. Here's your, at this point, this would be Bugs. Oh. What if that car was up there, the rabbit? I mean, the Bugs Bunny. If it was up here, as this falls down, he could have slowly been let off, like an elevator drop, if you will, and then be let off onto the underside of this. I love this now. So there's the flip. But let's say Bugs Bunny's up here, right? Well, I need more bridge decking up there, and I don't think there is in our video, but... Besides, it goes off the other side, doesn't it? Yep, it's gone. But you saw the flip. It was a beautiful flip of the structure. Yeah, agreed. Yeah, approximately the same location, and we get a beautiful rotation. Boom, and there's your rotation. And then Bugs Bunny, the football player, winds up on top of that structure. Just find it friggin' amazing that he did. Which would imply, again, that the right side was still up. And he drove off. And his car was so light, and he bought the kite car, the whatever it was, man. That car is just awesome. They need to advertise that car. And there's our thing. So there we go. And there's the structure being pulled over, blah, 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 blah. I'm getting something to drink. You guys can chat. I'll look at your chat. And what'd you say? Instruction porn. Yep. So do I leave this video up, guys, or do I take it down? after I'm done with it just now for this live view. Right there, guys, an expansion joint. Gives me my rotation, gets your push off. Expansion joint gets our brake. It gets me the extra load put on this on the cables to the point of braking. One of them allowing rotation. The other side coming over, as you saw in the seesaw effect, pushing it. The seesaw effect of the other side of the structure pushing over, then returning and then recovering backwards. Blah, la, 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 la. Can't get the joint though. I don't know the joint. Can't find any specs on it. But there's your bracing again. And there's that part that acts as it helps with the cantilever, this decking here. These cross braces. Hey Gordon. I think it is. That's a protective house, so we can't really see, you know, what's going on here. Does it go all the way up and over, or is it interlocked there? I would hope it was locked in here. And you see they allow for inspection on their product, although apparently they're not really inspecting it. 20 years, somebody's bragging about not inspecting their bridge for 20 years. I don't mean it bragging. And this is that joint. This is like the ladder coming up. You start pulling on one, you compression on one side, tension on the other. This is things you can look for. And if you guys remember, I talked about the rebar speaking to you. You saw it was elongated. If it was here and broke, then it would bend at 90 or whatever. I agree. I wouldn't want to see. I would like to see it locked. And that's just the guy gonna crawl up there. Wow, it's beautiful, isn't it? Now, I saw this on the other structure. Now I was trying to find out where it was, and I just saw it just now. He's going between the members. This right here drove me crazy trying to find it. Now here it is on this bridge. It's this reveal here, guys, and I don't even know where that image is anymore. Huh? I think he just went. He's at the base. I could be getting images mixed up. If you notice that the load path on our structure comes here and then goes straight down. On this load path, look, it comes down and meets there, and this one comes down and meets there. Our load path comes here, changes directions, and comes down this way. They allow the load path to go straight through. So there's your update, your upgrade, if you will. I love load paths. They tell you the story, all this stuff tells you the story. And there's your unsupported span between the two of them. And there's your side profile, and there's your member again. To get failure in there, you got to kill them all. to get that rotation my man spoke of. And it would have to be internally. You couldn't see the. I don't get it. To get it, I wouldn't get all that. But I'm not saying it can't happen, because I think it happened in the South Carolina bridge. And now there's what it looks like from this side of it. Different detail. Now we're down. It looks like 2 supporting members and not 4. And there's the part there that is it resting on or not. That might be the daylight I thought I saw right there from the underside. In reality, I'm not seeing, it could be resting on it fully then, and I didn't really see daylight. I can see now where I could have misinterpreted that. Because they didn't build out to the corner of it. I don't know about you guys, but I was like, what's this? It's my ladder. I got confused on everything I was looking at was video. So here we go. So there's your load path, you know, going down two separate columns. We've been here already. Compressive all the way down to here, and then splitting left off and left and righty. Left and righty, and there's a tie right here. Look, guys, this is out in the ocean. We're talking about winds now. This thing about winds and 17-mile-an-hour winds it was that day. This is out in the ocean, and this thing is not, it's not fallen to the ground yet. I'm not saying it's not on his last leg. You know, it takes a lot of work to figure out how this structurally is going to work out, but I'm saying it's performing at this point. Beautifully so. What you got for me? Well, 11 people watching. I guess it's just the 11 of us. So am I hocus pocusing, magic act? You know what a magic act is, guys? That's where I just disappear. The road deck. Let's see if I can find that. Oh, did you guys see this? I talked to you guys about jacking, people jacking videos. You know, jacking, you know, how they're getting ahead of the video links and all that. As you can see right here, I said the Genoa Bridge Collapse. Right there, but you see what image they did? You guys see that CBC News, 151,000 views, right? What did they use? They used the image of the FIU bridge collapse. Because Google uses image searching to help you do things. So anybody searching this winds up here, so they're hijacking people's searches over to their stuff. This is some creepy stuff, man, people do for YouTube videos. I'm just going to walk around naked and see if anybody wants to see that. But that's some nasty stuff. Alright, I'm going to back this out because I want to find a video showing that one I found initially, the first. I guess I can go to my first video. Past midnight here. Alright, Gordon. Me too, man. It's not midnight, but I'm done too. You're leaving. I'm leaving before you just for that. Got to beat you guys to leaving. I'm going to run out the house first. I was hoping to find that video of the guy going over the bridge. Oh, you know what? Let me go back in time. It was 2 years ago or something. I wonder what this guy's doing. Some jerk doing a video. Oh, wait a minute, that's me. Oh. want to show you that. I'm going to see if I can find it to show you that dip in the road. Look at that. They bar entry. That's almost worth looking at. Almost. Let me find that damn guys. That's not the structure, that's another hijack. And there's that car. Oh, that was me. There's my video there. There's that damn car. I want to find that one video for you. And I could is this it? Before collapse. 1 week ago. No. I think I'll do it though. Well, live from Genoa. No, that's... Yeah, the rubber duck. Open link in a new tab. I've got to see if it's that one. You'll see that. I want to show that dip in that road. Maybe. I don't think it's zip, but maybe it will still show it. Let's run this on. It would be to the right, how I recall it. You can see all of a sudden it's a step up and down. It'll be pretty evident when I saw it. Here's our expansion joint. There's all the dead loads added. This is actually the section that collapsed. No, that's not it. It was like a year or 2 years ago somebody posted, I made a comment to them. So I should be able to go to my comments and find it. I said, thank you for keeping this up. Something to that effect. Or thank you for having this up. And this is way before the bridge collapse. That's why I'm trying to find something more than 2 weeks old. Damn it. And it won't let me, it just says this year. I want something, you know, a year old. Okay, less than 4 minutes. Let me fast forward, guys. Let me just bounce some pages here. Let me get to the bottom. I can try to jump pages. Well, that's not working. They just keep giving me more and more. Let me try. There we go. We'll try view count, and then I could maybe go less. It still doesn't let me filter to less. It probably had 3,000 views. It's not going to work. I can't get to the bottom. Let's run this one. 40 seconds. Ooh. So this is the repaired structure section here. You see the cabling, the external cabling on it. There's the dead load I keep crying about. Appears they use one lane into two. Oh yeah, merging lane, got it. Merging onto the structure from a road directly onto the bridge. That's an interesting turn, literally. Now again, I'm trying to find that dip I can show you. Well, it looks like a step down maybe. Let's see. Yep, he just did a hop down. So there's a hop. What the hell? Come on. Alright, this is the one that's still standing, this section, and the second section is the one that's gone. Again, I'm looking for that damn dip, guys. It was so evident. And now we're going to end the video after that. Come on, maybe I should end it now, but let's... Where is that dip? So now we're on the existing structure that's left. We're about to cross off it just about now. There's that big ass barrier, someone said, way taller than 2 feet. So they added a lot of dead load. And you can see the asphalt changing color, so they're doing this craziness. Not sure what's going on here. There's your expansion joint. That's the part that it broke free. 8 inches of asphalt, ridiculous thick. Yes, sir. Yes, sir. And then here we are. We're going to the failed section. And there's your wrapping. And this is what my man said close to the window. That's the close to the window side, and that's the two split off of the cabling I was saying. It pretty damn difficult, I think, to get multiple failures in there, and the concrete elongation would show in that as a breakage separation. You can't elongate the cables without elongating the concrete, right? Or showing separation. Fork cables, yep. So there we go. And we're looking at it now. Right there is that joint. This is what I'm saying caused that rotation. Let me grab my drink. Here we go. This is what caused that rotation right there. And this structure that's gone, we're looking right at it now. Here is where I'm thinking it broke, somewhere in here. Right about here. You can see the two different asphalts, so they just did a layer. Two different colors. They've been working on this thing for a minute. They just added another layer. If you look to the left, that's a darker color and also a lighter color of yellow. Yellowish or whatever color you guys see it as. And darker, so this was redone. Who knows if they milled it, lowered it, or did they just elevate it? If we can see a car pop over, then we know that it's elevated even more. We can look at the edge here and try to determine that too. If we knew what this was, as you put it down on top of a structure, is this the regular reveal? Incidentally, it does look like a regular reveal of a normal, typical structure. This is all concrete. We know that to be railing in the structure. It should be in the other structures. Not this dead load they added. Somebody got a boat. Let's see. And here's our segmented formed bridge, stacked bridge. So there's your barrier protection. So no one ran into that damn thing without taking out those. I don't think that's going to happen. You're not going to be able to get the angle, create any real forces to take that out. And then we're coming up on the second. This is the one to the right that maintained and did the rotation of this section of deck we're on it now, roughly right about here. It rotated and buried itself inside the ground upwards. These barriers here not being present slid off. You would know, finding these barriers, you would know where to find where it did all this rotation at, you know, where it went to the ground. It might have been catapulted a little bit, but you'd still have data. And there's the patchwork. of the existing deck. I'm not seeing any, well, maybe that might be out to the right, not up and down, giving an illusion that it's going up and down. It's not what I saw, guys. I saw that damn thing. I was like, whoa, put myself to a stop on it. Now that's the expansion joint. And at this point, they no longer did the repairs. We didn't catch that, did we? Let's go back. The joints changed over. They changed over. So we don't have any dividing lines yet. And at some point, we can see where they changed. Truss for traffic sign is missing. The truss for traffic. Why is that? I wonder what that is. I mean, the horizontal steel truss spanning between the pylons. Oh, you know, different, this might have been a one-off, you know, the first one, an Italian design, if you will, with the, with this fork design with the concrete wrapping for protection of weather elements, blah, blah, blah. And there's expansion joint there. I might have to cross the line and go into my, and here we go. There's a repair there, stopping and changing over to the white lines again. So that was the last deck repair, and it's at a joint. It's at a joint. They have not even installed the lines in this video. Usually install the lines immediately, right? Let me cross the line here and do something here. Let's go to my secret stash. Go to my secret stash of screenshots that I've snatched out of different videos over watching a million times and trying to steal data out of it. I don't mean steal, you know, get data. So we have that rotated bridge here. Let me put down my little, give you guys a better angle. Okay, so we have that rotated section here. Peg. This is night images. Construction crew is there. They're back there on the back side. There's that bridge, that part that slid down. We're looking at it quite a little bit on the skew with the drone image, and the data is from Vigilant Del Fire Company, wherever they are. Next image. Oh, I didn't give you. I can come out a little bit. Hold on. There, the two cameras are still will be present here, as this is not compressed or damaged. So two cameras clearly should be okay on the wall. One pointing in this direction and one pointing apparently down in that direction. It has not been revealed of what it has to offer, if anything at all. This is that bridge section that I trolled the initial time, and then when I came back to here, this bridge is unbroken here, so we know no failure happened at this point. There's your center columns, all in perfect shape. You remember I called BS on it immediately when they said it was the foundation repairs. I said that's another lie that they're trying to put out like the weather. And there's the close-up of this one. No, it's Alpine. It's a different angle. That's coming off. You could see the roof in that street sweeper. This bridge, maybe it's in here, Alpine. It might be in my screenshots to show you that camera would have not been. It's another camera. I had myself and a few other people here. We really walked up and down each street looking for cameras. We found them everywhere, from in gas stations to behind buildings that would give us render us no image at all. But mostly there was no video cameras. Well, there was one right there, right? But it's been cropped. The camera I'm talking about is right here. If you look here, Alpine. There's two cameras here. You can Google it. You can get on the street and look and find two cameras here. You get staying on the street, Alpine. You look back here, and you'll see a second camera right here where my mouse is pointing to. I think I put the image of that. The next image puts the other camera out in the middle of the street. This is that decking. We see what's on top of it, so that tells you the sequence of collapse. Alpine said a comment, and it says, no, that is the second shot, about 12 meters from exactly. That is what I wrote. Okay. Here we have these guys, and once again, this top shot. Camera behind this guy. Well, he put his label right there. Vigil del Filici, whatever the heck it is, right over the damn camera. Normally they put their labels to the left. Now I'm seeing it to the right here. You know, I can't help but say conspiracy stuff, God. I can't. Why would you do that? Okay, what we're to the right, and this time is not blocking the camera. Cool. We agree. So then there's that rotated bridge structure, slightly rotated, and this one's, well, they have, this is the one of the construction removal. We got a lot of debris in the air. Again, there's that rotated dive in the ground. There's the flip bridge. There's the car. Orientation-wise, here's the structure. Here's the member on top. As you see, this member's on top of that center cribbing, if you will, that center bracing. You see nothing underneath of it, guys. This bridge fell away, like parting the sea. Away. Not straight down. Not straight down. Nothing's underneath of that. It's upright. Okay. Moving on. Again, you see here's the line of the structure here. This is slightly rotated, and it's now under the tracks. Using sky view and going down on the road down here by here and looking up at the bridge. This and a cable that was hanging from here. This all looks to be behind this line, this plumb line, if you will, at the edge of the structure, which means a secondary force had to push it over. Unless it's on a hill. If this is on a hill up to the left and that's all the way down to the right, possibly during a collapse on the hill, it could explain it, but I don't think I think it's level, right? It's just a thought. You still want to fall straight down the hill, but I still have to account for it. There's the top view again. There's the one you see it leaning that way. There's no debris down there. Here's where the hanging car was, where you saw the fireman pulling someone out of a body, I believe, out of a car that's been destroyed. As it went away, the car obviously went down and got mangled up a bit. Here's part of that structure. Here's the brace. Here's that connection. The brace going this way and that way. This brace would have been the top. As you look at my ladder, it would have been the top part from here to this side, the two sides together, and it's halfway going that direction to that one, and that would be laser going under laser now. This brace here. This is the top part. If we were doing a flyover, looking down at the bridge, this would be the very top. This would be the part going down. This would be where your joint is going left, coming down, and the joint to the right. The red MCM Auto Sporty truck was under the bridge, partially on the railroad tracks. The trailer was empty. Thank you, Alpine. Top view, you see all the debris pretty much on the right side, that these guys were able to get the machinery in real quick. Everything went to the right, which you would think that the failure started to the right, because everything already was in that direction on this side of the structure to the right. So that puts our failure looking to the right on this side, but that's on this side. Don't be misled by everything. This one, if we follow this plane, I don't know where, because I don't have the other structure there. I can't tie it in, and I don't know if they did a rotation of this. So it's kind of corrupt, but this is the member. There's our car. Up here is where it was connected typically, and then it did a flip. We're looking at the underside of the bridge right now, and the road deck is facing down on the tracks. You can see them removing it. Removing the debris, and this is they made a ramp. I spent hours watching this, trying to get the data immediately, and as you were getting it, because it was live view. I'm glad I did, because they since removed that video. You cannot find 11-hour video, as far as I know, anymore. 11 plus hours of it. And thank you, viewer, for sending me to that, looking for it. They actually sent it to me, and my dumb ass spent 11 hours doing it. They said in fast motion. Now back here is that a vehicle took a dive, but that's that one side. We can discount this pretty much for too much data. This is not the I think I was showing that in this one Car was of interest. I've saved all these lengthy videos. Oh, that's cool. Here's the crazy guys doing that crazy because this structure is going to have to be demolitioned. It should be. And they're now securing pieces that might fall and stuff like that. Get a damn wrecking ball, get whatever you got out there, blast the damn thing. But you know what? They're trying to save property down below at the expense of these people's lives. Now, I wouldn't trust a damn engineer at all to evaluate this structure. You didn't evaluate it properly the first time. Not if I was these guys. Myself, I'd like to evaluate it. Well, you know, it would take some time. You're not going to get the evaluation done in the short order that they put their lives at risk up here. No. Oh, this is actually they showed in the mapping room when they were working on the structure, which is them giving away data, guys. They've zoned this out. Look, here's a green zone. Here's another red zone, and they then made these two zones of the same color. You can extrapolate why they zoned it. Maybe it's crews, but then if it was crews, why are the same crew here? But it's just zones, guys. This is data that later on you can evaluate. So if they say something, go, wait a minute, that doesn't jive with the with your zones, the way you zone things. Team blankety up here, see team something, and these are zones. Also showing the debris field, if you will, in a straight line effect, if you will. All right, this is underside structure, and you know that at this point they're demoing, so this is a lot of corruption, but nevertheless it's showing that these are undamaged. Undamaged, guys. And now we're looking at the top of it sitting there. That's that ripping. I'm going to get a lot more data out of these, but we're going back to the other side where the building is on this side. This is that decking. There is the Jersey barriers. Down here is that other brace to the top of the pylon. Here's where you would look for if there was something nefarious, no explosions and things like that. Does not look to be anything like that. And obviously they were able to hire a crane to do things kind of safely, but not to the top of that structure, obviously. People going crazy circling this. This is where everything is. This is the problem. Whatever. Bite me, I say. Now here's that bridge there. The cables are no longer plumbing. Oh, it's a piece of equipment, guys. They're tracking this thing beautifully to show movement and all. This is what the equipment. That's what this equipment does. It's like a scanner, and it will tell you whether things move. It won't move, and it'll tell you what's moving here, if at all. Beautiful stuff, guys. This tracking equipment. And that's what it looks like. And that's what it looks like if you're taking shooting a guy doing it. And that one's not worth looking at. And that's just comments somebody asked me about. Oh, that's somebody told me. This is a disgusting person saying insert here. So I'm at the end of that. I was going to troll them back. They didn't give me a chance to troll them back with their own comments showing them how trashy they were. So now we're off point. So we'll get away from that. It's about boycotting South Africa with the food stuff. And she was saying that whatever she was saying. All right. But then I got her to back down, and that was it. So now where are we? I can't go into the other screenshots I have because it would ruin the video, because I'd have to see if I had my own personal data on it. And that's that. That damn video, guys. I guess I won't be finding it. 3 years ago. Oh, we might be getting lucky. 3 years ago. Did I comment on this one? I do not think I did. Nope. I don't think this is it, but let's go with 3 years ago. And I don't think it's the video, guys. It was kind of a short video, as I recall. This isn't it because I commented on the video. So this is not it either. Let me just scrub the video real quick. Looking for the towers. When I scrub it, looking just for the pylons. No, there's nothing there. Alright, no luck. No luck. Genoa Bridge, no luck. Who knows, maybe I'll get lucky. A lot of Genoa searches, as you can see. Let me jump down to the bottom. Now, looks like I might have cleared my old thing on that. And I just cleared everything I ever searched for Genoa. 240. Done. That takes care of that search for Google sending me anything about Genoa anymore. Okay. Anybody else got something to say before I roll out? Strange these rescuers were not safely lying to. It's worse than that, man. Lying to a hovering helicopter above the surveillance camera. Black shiny roof shot. They were mounting a monitor. What? Really? Well, with that said, let's go with one more time. The let's see what they have latest. Says 23 hours ago. Anything new? I don't think it looks like that, does it? They even hijacked John McCain in the Genoa Bridge Collapse. Somebody did. That's the only way you give it to politicians in the U.S. They got to die off. I don't care about John McCain. What do you do for me? Nothing. I still remember the Vietnam stuff about him. They called him the singing bird. Now, I don't know if that triggers any of you guys. But, okay. Looks like no current images, nothing worth exploring. These are old images. They're recycling the last 24 hours. They're just recycling them. Even went as far as IKEA down this road looking for cameras, guys. Remember, it was raining that night, so that day. So even if I found a camera down there, I might see nothing but rain. But nevertheless, I explored that. You can see the cable breaking free there. Okay, Magic Act time. Magic Act. Okay, you sent me a link. All right, I might have to look at this. Let's see. Uh-oh. Might be. See if I comment it. It was a lady too, I think. Yep, this is it. Thanks for the video. Come on, baby, you better show it. Or it might have been the one with the car, with the awesome, you found it. The one with the police cars behind it holding up traffic. Well, let's go with this. I'm looking to the right. Yeah, it did, Alpine. Awesome. Because one when the police cars are going very slow across the bridge, holding up traffic, well, purposely holding traffic, guiding traffic. There we go, right there. That's it, Alpine. Right here, guys, that's a transition. This thing goes down and then up. Great cooperation, you're telling me. Right here, Alpine, this is the dive I'm talking about. This is down. That's another elevation. That explains my creep that I'm talking about was on that bridge. That's evidently on that bridge. That it's amazing. This dip. What do I say? Anything else? Only one available at this time for accident. Someone gave 3 thumbs up. Yeah, I wrote that. Please do not take down your video. Right. 2 weeks ago I said that. All right, there we there's a dip down and up. And then up and okay. Now we're back on the structure. Yeah, that makes you wonder, Alpine. One more time, back this chumpy up. I wish we, and there we go. One more time, back up again. Up, down and up. So traveling into this is the collapse one we're in now. Transitioning out of the collapse one. Into the cables. And then right here, and the cables, that you can see right here, roughly at the end, we have our transitioning deck. Up and down. Here's elevation here. Here's the new elevation up here. Look at that elevation. Elevation changes. Clearly an indicator of this bridge no longer being not on the same plane. Look at the lines. Up and down, up and down. Now I could use this also, but we'd have to determine that the craftsmanship was dead center of this. Would show it up and down. Damn humpback. Straight across, up and down. Yeah, so it's showing you that you're getting some settlement, some sagging. And this is where I put my brake at, guys. If you remember my brake, I put it roughly over here. For that reason, you can pick each side of that you want it to brake on. Put it on that side or this side. But I also put it back here behind this because I need rotation. You can move it for me. We can play around moving it, but I don't want to do that this time. Yep, back up. Back up. Ugh. There we go. Boom. Now you can see the car having to go up and down. The camera, he's not, let's see if she's free balling it, right? If she just got a handheld. Yeah, they're zooming, so I'm thinking this is freehand. Okay, so up. And hit the bump and go down. Boom. And back up. You know, the person's taking a ride up and down like a damn seesaw on this bridge. Look. Seesaw ride. Alright, Alpine, awesome. I can't end it better than that, man. Let me get your link down there. Alpine, line this thing up. So I go over here and say, this is what you get for free. All right, Alpine. Thanks, Alpine. Hopefully that link will work. Let's link it up again. You're welcome, yeah. Alpine, Alpiner. Thanks, Alpine. I'm glad you enjoyed it, man. At least that's 2 of us. I'm teasing, of course. Anybody else, thanks for watching also. Glad you guys, I guess we can put this sort of to rest. I don't think another video is going to pop up. They seem like we've had enough time for other videos to surface. Perhaps Perhaps a timestamp will show up. Perhaps a larger video will show up of the same images. And maybe we'll have to do an update. But if no update is needed, then no update will be needed. Alright, so I'm going to now do the vanishing act, the magic trick. I should be able to press this and vanish on you. Take care. And as one video said on the other thing, I like it to say, appreciate you. That's what this little girl said in this other video.